Oh yeah, I'll tell you. You gotta love some of this music, you know. This is really cool. Boppity bop, yeah. Hey guys, welcome to SkyTour LiveStream. It's Mark Antonio here with Daryl Mason. Mason. In the background, Daryl, are you here?
Hi, yeah, I'm here, just barely.
Just barely. Yeah, he's here. Yeah, Daryl and I were on a little bit ahead of y'all, and just trying to show some, work on some objects. This is the Trifid Nebula. Now, to understand what's going on here, we actually have this beautiful set of filters that we use on the telescope, and these filters are, well, they're so good that they actually knock out most of the moonlight. The moon is not far from the Trifid Nebula right here, okay, and we can still see this blue reflection nebula up here and this red hydrogen 2 region with all these beautiful intricate lanes. And this is our somewhat wider narrow band. This isn't the very narrow band filter. But look at that, huh? That's beautiful. This, by the way, was a 2-minute exposure. So it really came out nice. I'm very happy with how the telescope is functioning. There's slight little issues here or there, and I've been tweaking it to try and get it to the right setup. But man, this is really pretty. So welcome, guys. It is August 25th, 2020. We are a month and 1 day from building the observatory out in Arizona. We actually have a final date. We will not be putting this off any longer. So we will be going out there on September 26th, and we're going to build it in the desert, and then we're going to build the roof separately. The roof will be metal, and we're going to then put rails and have a sliding roof. And I'm going to hopefully do the same thing with the observatory here. And we're going to make this a roll-off roof, automated and everything, just like out there. So now we'll have 2 fully automated systems where I won't have to go out and brave bears and now mountain lions in our area. We got mountain lions in here now. We got a photo of one about just under a mile away from the house. And their territory is bigger than a mile. So it's pretty, you know, it's not fun walking out to the dome with your head in a swivel, looking around, seeing what's out there, you know. Ooh. So I still want to bring you this stuff, so I don't want to get bitten by anything or attacked by something. I want to say hi to Anahata77 and Tara, and of course Daryl's right here, and Gina Leone's here with us, along with Calibos. How you doing, Calibos? And Daisy and Zoe Amethyst. You know, my loyal followers here, and love to see what we do here. It's so nice to see you guys out here. You're the early birds, let me tell you. And Andy Morrow's here too. And the first one, I saved him for last, is Governor Z-Ray. Hey, welcome to SkyTour LiveStream. So, I've been looking at cameras today, trying to figure out if I'm going to get a different camera. I was talking to Daryl about it a little earlier. And I'm not sure. There's an issue of clearance, and that's not as in secrecy, but clearance under the telescope as it swivels. That camera's big, you know. It's about 4 inches long, and it sticks way out from the back of the scope, causes balance issues. So, not sure the best way to do it. I could put a diagonal in and have it be pointing down into the scope, but that changes a lot of things, and I don't want to have extra glass between you and your image, you know. Hey Marco, how you doing? Nice to see you. So what we did was, the moon is somewhat near this. Actually, I'll show you how near. Let me just bring up that whole illustration to show you. So here is our view. I see there's at least 1 or 2 new people out here. This is our telescope control section. This is me down the bottom here. Hello. Okay. And this is the telescope view in the dome. That's that disc you see right at the top there. That's the automated cover that opens and closes automatically when the telescope is closed for the night. And this is the camera control cluster over here. And this is the live view. We can control the telescope here by just moving things around. As you'll see when I hit this, you can see that we go a little bit east. Now we go a little bit west. Now that east and west is pointing the telescope, moving the telescope. So if you go east, you think it's on the right, so it's actually you're thinking it's gonna go that way. Well, east is to the left over here, all right, and west is to the right. So when you hit west, it's kind of like the rudder pedals on an airplane for any of you who might know how to fly. So that's kind of how it works. You push the left pedal to go right with the rudder, and you push the right pedal to go left. Not a mistake you want to make in the air, I can promise you that. And luckily, the people that fly have it drilled into their heads. So we're looking at the Trifid Nebula. It's the best part about the Trifid is it's actually one of these nebulae. Here's the zoomed image here. This is the two stars that we see in the center when we go over to this other view here. Let me just get rid of this for a second. These are the two stars we're seeing right here. And this is really just a beautiful nebula with these beautiful little, that's why it's called a trifid, because there's these dark lanes. And Daryl, you've talked about dark lanes in galaxies too, and these dark lanes are due to the same thing that we see on a larger scale in galaxies. It just all adds up,
Yeah, dust.
Yeah, dust. Yep.
Clouds of dark stuff.
Yep.
Not dark matter, as Ronald keeps asking, though.
Yeah. Is he asked tonight? I guess I haven't seen him here.
I haven't seen him here tonight, but he asked it last time, and he's asked it before.
Yeah, there's a confusion.
Just run-of-the-mill dark stuff.
Yeah. Hey, would you like to? You want to tell people about dark matter, or you want me to go through? You let me know.
I don't believe in dark matter, so you better do it.
Okay. Well, the concept is that when we look at the galaxy, galaxies, they tend to, they're rotating. That is, the stars are going around their nuclei, the center of the galaxies. We've gone around our galaxy almost 20 times in the 4.6 billion years since we have been incepted. Okay, and this almost 20 times is something that is interesting for a lot of reasons. It causes problems for us trying to figure out what's happened, what the past looked like. But just like with our solar system, we look at our solar system. Mercury is closest to the sun, and it goes around the sun fast, every 88 days. That's fast for a planet, right? I mean, there are faster ones in the outer, in the outer reaches where we look at exoplanets. But the farthest planets from the sun go at a much more slow and leisurely, lazy pace. Pluto takes over 250 years to go around the sun, and Mercury takes 88 days. So we expand that and say, well, in a galaxy where all the stars are going around the center of the galaxy, no, this is not a galaxy we're looking at here, of course, but all the stars going around the center of a galaxy, we thought, classically, that the stars near the center would be going faster around the center than the stars on the outside, okay? Because they would be going leisurely to go around the galaxy, and we thought that would be the case. However, facts get in the way, and the facts indicate that the galaxy actually rotates almost like a rigid disk, meaning that the stars in the middle here are rotating slower than we thought, and the stars on the outside are going much, much faster than we thought. That was crazy. So, hey, Dagger and Rock, it was very hard for us to put that together and figure out what that meant. So, in this, you can understand why Daryl says he doesn't believe in dark matter, because that's where dark matter, the theory of dark matter comes from. And it is that there is another matter. Every bit of matter that we see and can measure and so forth in the universe is protons, neutrons, electrons, muons, gluons, so-ons, all on down the line. But if you look at this rotation rate, the only thing that can explain so far, the only thing that can explain why the galaxy seems to rotate in a rigid disk is if there's some other matter that we cannot detect. And that matter, because we don't know what it is or know anything about it, that was why the term dark was added to it. It's not dark because it's black. It's dark because it's an unknown. It's like the black box. We don't know what's in the black box. Okay, what's in the black box? I don't know. It's a black box. All right. So that said, dark matter has become this entity that explains why galaxies will rotate in a rigid disk. Because with all that extra matter, then the stars don't have a rotation rate that's dependent on their location from the center of the galaxy as much. Right? There are differences, but it's not what we expect. And
can I jump in here?
Of course you can. I want to hear your side.
Well, it's not that I don't buy the argument. I understand what you're saying about galaxies, and something must be out there adding the weight. I just don't buy all the exotic stuff. It seems like that they're letting the models run away from reality. That's what I don't like. That's a problem I have with so much climate science. Science in quotes. Maybe there's a lot of black holes out there. Many black holes. Who knows?
Yeah.
Maybe there's a lot more that we don't see.
It's possible.
But, I think it's navel gazing at some point.
Hang on, I'm sorry, I didn't hear you. I was staring at my belly button. What'd you say? No, I was kidding.
Yeah.
No, I think that you could be right, Daryl, and but the reason, dark matter wasn't thought of and then thrown out there and say, okay, dark matter it is. There's actually science to detect dark matter. There's science to detect dark energy as well. There's a dark energy telescope, in fact, that's meant to detect just the dark energy interactions, which explain why the universe is expanding in an accelerating rate. That's what the dark energy element explains. It's a whole nother thing. But
I don't think I'd buy that either.
I figured you wouldn't.
No.
And that's okay.
Well, I'm like Hoyle and the old steady state crowd versus the Big Bang Theory, I guess I'm just a dinosaur.
Except that you don't necessarily believe that it's a steady state universe, right?
No, I believe in an oscillating universe. I believe in the yin yang of the Big Bang. Those almost rhyme,
They actually do rhyme. They rhyme perfectly. The yin yang of the Big Bang. Hey, that's a book title, Daryl.
Yeah. Someday, maybe.
Yeah.
That's just what I cut my teeth on, what theories were at the time. I have a book put out by Scientific American a long time ago about the Big Bang and, the universe as it was understood back then. This is like 70s or 80s vintage, I think. And,
yeah.
It's all been supplanted by more modern theories, and I'm kind of still stuck with where I was when I read that. The whole idea of an oscillating universe. That the idea that the universe is accelerating its expansion just rubs me the wrong way.
It rubbed a lot of people the wrong way, but when Hubble in 1929 came up with the Hubble constant, it was
Hubble was a homeboy. Be careful.
I know. He was one of the greatest astronomers known, and when you look at how Edwin P. Hubble determined that Hubble constant, he was studying galaxies and their recessional rates, that is the rate at which they're speeding away from us. And looking in every direction, he figured out that at that moment, the universe was expanding at a certain rate. And that became the Hubble constant. We figured that this was obviously well over 12 to 13 billion, I'll tell you why I said 12 to 13, a billion years after the universe began. And that seemed to indicate that this acceleration outward should do one of two things. It should keep going, all right, or it should slow, and then the universe would then, like with the mutual gravity of everything inside the universe, pull it back to a bang again and just do this oscillating thing, which is what you're talking about, which seemed logical to me for many, many years. Or it wasn't actually expanding at all, and the Hubble constant was a mistake. Well, that was rejected roundly by science, and we realized that the universe is actually moving Everything in the universe is moving away from everything else. And if you think about that, it almost doesn't seem to make sense. But we're talking about global scales here. Within galaxy clusters, the galaxies are moving toward each other, going to orbit each other, like we have the Andromeda galaxy coming toward us. You know, we're going to pass through, it'll pass through us at some point in several billion years. Well, so at localized, things will be moving toward each other and so forth. But at the global scale, all those clusters of galaxies are actually moving away from each other. And how you can visualize that is with a metaphor I used way in the early days of SkyTour radio, and I mentioned, imagine you have a balloon that's deflated and you put all these little black dots on it with a Sharpie, okay? And then you blow the balloon up a little bit, all right? And you see where all the black dots are. You measure the distance between them, dot to dot, and you'll see that it's a certain value maybe. Then you blow the balloon up and you watch every dot move away from every other dot as it expands out. That is the principle of the universe expansion, in a sort of in a balloon, okay? But
also known as the raisin bread scenario.
And there's also the raisin bread scenario as well, okay? You can explain that too if you like, because I use the balloon one myself, but the raisin bread is just as valid.
Well, you could construe the balloon example as sort of 2 dimensions projected onto the face of a balloon, gets to 3 dimensions. The raisin bread scenario says you make a roll of raisin bread, you put it in the pan and you let it rise. And as it rises, those raisins get farther and farther apart from each other. And the farther apart they were in the first place, the faster they're moving apart from each other.
Yeah.
That's more of a 3-dimensional scenario, and you'd want to extrapolate that to a 4th dimension, I guess.
Well, yeah, just over time it does that.
Basically, that's it. The problem I have is when science becomes gospel, okay? Hubble's science, the Hubble constant, was gospel for a long time.
Yes, it was.
Relativity, Einstein, has become gospel. If anything is gospel nowadays, it's relativity.
Yeah.
But, as somebody said in chat, that science is supposed to be flexible enough to accept change and new data. And maybe that's my problem now, is that I'm old and cranky and can't accept new data. But, I have no doubt that one day relativity is going to be knocked down a notch or two.
I don't doubt that. Actually, I don't doubt that. I mean, here's a simple one. For all of you listening too, we believe, that matter is composed of atoms. We believe that atoms are composed of protons, neutrons, electrons, etc. And we also believe that each proton and each neutron is made up of several other fundamental particles called quarks, right? And we talked about that on SkyTour Radio this past week. And that's 3 quarks apiece to make each a proton or a neutron. And the matter, they have characteristics that make them positive charge for the proton and 0 charge for the neutron. Well, what are quarks made of? And the answer we get is we're not sure. But right now we're operating our science on the basis and assumption that these are elementary particles. There's nothing smaller. Yet science is flexible enough to know that may not be true. Okay? And that's the thing that and that's actually the reason I got into astronomy, believe it or not, too, was because I knew that the science was always going to be changing. It was always going to be exciting. It was never going to become static, and it hasn't. Like the universe, everything's in motion in the science of astronomy. The more we learn, it seems like the less we know. But for the most part, it's not like our equations are incorrect. It's not like our calculations are incorrect. I mean, if we didn't have a good handle on science, we would never be able to get to Pluto with precision and get to Ultima Thule with precision like we did. We'd never be able to land on a comet, land on an asteroid. We'd never have been able to do that if our science was just blatantly wrong. So clearly we have something that we're doing right. And little by little, the science will self-correct over time. We see that now. People used to think, for instance, that some principles were set in stone. There were people that used to think that dinosaurs and people coexisted at the same time. But then they started to understand faulting and tectonic shift, and they understood how sometimes you could actually get layers flipped upside down, and would make it look like dinosaurs existed after people in a certain region. And once we knew that, we could actually then identify it. And once we started doing radioactive dating of objects, then we realized this structure has been flipped over. And so that kind of thing is also very important to do. And that's an example of evolving science, So I'm still taking pictures of the Trifid Nebula here, because I'm just honing in on the guiding issue here. I'm just trying to make sure that the guiding stars, see how they're little ovals? I want those to be perfectly round. So I'm making little adjustments. And we're doing that tonight, but we're talking to you at the same time. We're having fun. You see what I mean, Daryl, about that when I talk about, science has to be honed. And so that's why I don't dispute what you say. I mean, I'm open-minded. I know that. I know that what you're saying could be true.
I understand. A couple hundred years ago, people found it hard to believe that fossil seashells could be found on top of mountains, like in the Alps. I don't remember the guy's name. I think he was French. He was an early geologist, and he looked into it and figured it out.
Yep.
I just don't like the idea of science, A, becoming gospel, and B, being politicized. And I'm going to leave it right there.
Well, that is very true.
And that is happening a lot nowadays.
Yeah, I can't stand the politicization of science. That kills me. Okay, for instance, there's a COVID cure. Did you guys know that? Ivermectin. Ivermectin with zinc and doxycycline is a triple punch that in Australia has cured people 100% who have had COVID. No failures. So why?
I can give you another example.
Why isn't that here?
Yep. Well, they're working on it.
We don't need a vaccine.
A certain guy with orange hair mentioned hydroxychloroquine, and instantly a whole bunch of people were against hydroxychloroquine.
Yeah.
I've seen positive, I've seen negative articles about it. I'm just a layman, but there's a good channel on YouTube called The History Guy, where he does little, about 15-minute segments on interesting events through history that he says should be remembered. And he did one episode on the Spanish flu, and he was showing lots of newspaper clippings of the time. This is just after World War II.
Yeah.
And the word quinine appeared a lot in the press.
Yeah.
They were using it back then, and some people said that it worked, combating the Spanish flu. And, quinine is a sort of a historical precedent of hydroxychloroquine.
Yes, that's correct.
And the reason that so many people are against hydroxychloroquine is political, entirely political.
That's
because
right.
Orange man bad, okay?
Yeah.
It's that simple.
Well, this is about healing people. It's not about politics, and I get so mad. Both sides do it, and I cannot stand it, to be honest with you. There's always an agenda. Why does there have to be an agenda? Especially with this. This is people dying. So I don't think there should be any kind of agenda whatsoever.
Well, the other side of the whole HCQ thing, and maybe the others, like the drug you mentioned, it's big medicine or not. HCQ is already out there. It's cheap.
Yeah,
and,
so is
you're not going to be able to sell your $1 billion cure if there's already a cheap drug out there that will cure it.
That's right.
So there's motivations out there that aren't being mentioned. And so many people just take it all as gospel.
Yeah, ivermectin has been around since the 70s. And, of course, doxycycline has been around for a long time. And zinc, it's a mineral in our strata. So clearly, I think that when you look at this knowledge, I actually feel very comfortable now, knowing that this is available, because this means, and I'm not just jumping on something that might be a cure. This is something that's actually been shown. Every one of those are FDA approved drugs, okay, except zinc, obviously. So I think we should give it a shot. What is to lose? What's to lose? And as soon as, if somebody on one side says, oh, ivermectin, then someone on the other side is going to say, hasn't been proven, can't do it. Why? Because it'll make you look better than our guy. That's the stupid, almost said the bad word. That's the stupid stuff, okay, that we just have to get rid of. I cannot stomach that. Obviously you can't either. I mean, we're both on the same page with this, I think.
Yeah. Let's do some astronomy.
I know, we're having fun with astronomy, actually. I'm actually just tuning my, the declination, I'm tuning the declination correction here. And doing another shot. This is actually the most I've tuned it since we actually got it and started installing it. Hey Dagger, thank you so much. That's very nice. Okay, now we're going to take another shot. I'm getting so excited because we're so close. I got to say hi to Marianne Robb out there in the chat, and Nick MWM, and of course the Ally is here, and Eugene Schnitger is here. I met Eugene out in Wyoming. Really cool guy. And I just wanted to... Oh, and Gas Mask. Hey, how you doing? Well, a Gas Mask... the ivermectin drug and the doxycycline, they are so cheap that they actually wouldn't, give Big Pharma any big money, actually. They're already available. They're already used. And ivermectin's an anti-parasitic. It ends dengue fever and so forth. I mean, so, and other flus. Okay? So I think that we're talking about something that is, it's a no-brainer. It's a no-brainer. It's a no-brainer to me. I don't know. No-brainer. I might be able to do something here, actually, now that I have this set up. That's okay. There we go. All right, and we can start this guy up again. And vitamin D is important too. Although too much of it's a bad thing. You can always put too much in. Gosh, look at this. This is beautiful.
That's true of a lot of things.
Yeah.
Now, I have seen studies that say vitamin D is better for COVID-19 than vitamin C is. They said vitamin C didn't seem to do much, and they're prescribing rather large doses of vitamin D.
Yeah. Yeah.
But as you say, too much of anything could be a bad thing.
That's correct. We all agree with that for sure, huh?
Yep. Vitamin A, a little bit's good for you. A lot's really bad for you.
Yep.
Don't ever eat a polar bear liver, for instance. That's got enough vitamin A that it'll kill you.
Really?
Yep. So lay off the polar bear liver.
Oh, man. Just when I was thinking I had a source of meat that would be endless for me, you have to go and spoil it. I'm joking, of course, because I hate liver. I can't eat liver. It's just... Ugh. Yes. Who can eat a blood filter? Ugh.
Yeah.
Ugh.
Hey, when I was a kid, we ate pretty low on the hog sometimes. We were not rich by any means. And my parents were hillbillies, and they tended to cook hillbilly food. Sometimes it was a whole lot like what Granny cooked on Beverly Hillbillies.
Jethro!
And she used to make a dish called liver mush.
Ooh.
which was one of my father's favorites. You chop up a liver
Ugh.
and you boil the life out of it, and then you throw in cornmeal mush.
Mm-hmm.
And when the cornmeal mush cooks, turns into mush, you take it and you spread the whole mixture in a pan and let it set up. Then you slice it and fry it, and hey, presto, liver mush. I read somewhere a long, long time ago that Benjamin Franklin, of all people, was raised on liver mush, and his family was desperately poor when he was a kid.
Yeah.
And one night at dinner, Ben said, "The liver mush looks a mite thin tonight." And his father beat the tar out of him. Ben Franklin ran away from home, and he never had to eat liver mush again. So there. Daggerspill loves liver mush.
Ugh. Ugh.
It takes all sorts.
Yes, it does, and I respect that people eat certain things, like Marianne, for instance.
I bet Marianne doesn't eat liver mush.
Are you kidding me? Remember,
She does like liver and onions, though, so I may have to reevaluate here.
I think you have to, because you have to understand that she was a big game hunter for a long time.
Oh, yeah.
And
I've seen her talk about squirrel stew before.
Oh, yeah, but that's not big game, okay? You go in the house and there's a, you know, because when I stay at their house, when I go out there, you start walking up the stairs to go upstairs to the spare bedroom, and there's a gigantic elk towering over your head. The head, of course. Because they got all their trophies on the wall. It was like, wow.
Sure.
And one of them is a little black squirrel sitting on a branch to look all so cutesy. Hey, I'm sorry, Marianne, but you know what? I was never a hunter, and so she's actually said she's not going to be hunting anymore, and I give her props for that, because now she had to go down the dove pate. Ugh. Hey, that's gross stuff, man. I'm sorry. I can't even get my arms around it. Never mind. I can't even get my head around that. Ugh.
Well, there were times our mom served us squirrel stew also.
Yeah.
And, you know, I was a little kid, and what? You took Robbie the squirrel and made stew out of him? And we ate frog legs, and we ate all sorts of stuff.
Yeah. Oh, yeah. I mean, I had frog legs once. It's
a lot of work.
Yeah.
For the return.
It is. But I will say this, okay? Marianne's a big fisher person now. I won't say fisherman because she's not a man. She likes to fish now, and her, thank you, Tara. Her fish fries are to die for, and not to die from. Okay, it's a little difference there. They're to die for. They are so very good. I remember I was doing a talk at the UFO Congress one year, and I had Douglas Trumbull with me because Doug and I are friends, and I got Doug in to speak at the conference, and I found out Doug and Jacques Vallée are very good friends, and so I got to meet Jacques, hang out with Doug, with Jacques for several days, and Doug and I were invited by Marianne to go over to Marianne's house and have a fish fry. And Doug still talks about it. I talked about it with him the other day, Marianne. He remembers that fish fry, and he remembers how nice everybody was, and he doesn't forget. So you did a really nice job. If you did a lousy job, he would just not talk about it. So.
Oh, that too. We grew up fishing, and my mom and dad were fishing pools, and one of the greatest moments of my dad's life was when he got his own fishing boat.
No.
You know, we'd go for crappie, bass, catfish. I never was much of a catfish fan. And when I first moved to Colorado, I was a fishing pool. I'd go fishing every chance I got. Basically, I quit fishing when I moved down here to the Springs because there's no good fishing water anywhere within a couple of hours of the place.
Yeah, okay.
And I eventually, maybe a philosophical thing, I came to the point that I figured the fish were better off in the water than, me pulling them out of it.
Yeah, my feeling was that if I have to survive, if it's the difference between me and survival, or survival and not survival, I would have to resort to hunting the land and fishing the seas and the lakes. But I don't need to do that. And yes, I realize that we are eating other animals that somebody else has killed. Okay, but I'm not gonna go out and kill additional animals. So I've never been a hunter. I can't see, interrupting the life of a large animal and destroying it. I just can't do that.
Well, there was a time here when I was young that I ate more elk than I did beef.
Wow.
But if not a survival thing, it was a budget thing. My sister and her husband, who very kindly helped me get my start here in Colorado, they weren't rich at the time, and her husband would go elk hunting each fall.
Yeah.
And, put it in the freezer, and that was their larder for much of the year.
Wow. By the way, Marianne says she's sitting on the side of the road with a broken down boat trailer.
I saw that.
I know she's moving the boat out of her house location, moving it to another house location as she prepares to get rid of that other house. But I didn't know that, Marianne. I'm sorry. I guess be entertained. I don't know. I mean, I don't know if you're watching this on. You must be watching this on your phone then. I'm a little tiny pink dot down in the lower left corner. But I could change that for you. I could say, okay, now you can see me, Marianne. Hi. But I know that's kind of bad, but
I'm going to scare everybody one of these days. I was fooling with my video camera today.
Really?
I remember what you said the other night. I may just throw you a live video of me sometime.
That's great. I would stack you
I don't know about that.
Stack you right up here, or put you over on the right. Instead of the observatory cam, I'll throw you in there.
We'll see.
Yeah, you deserve it. You deserve.
Not tonight.
Oh, I understand. But you definitely deserve it. Hey, Rock, thank you, man. Thank you, Rock. That's very nice. Wow. Oh. So, Marianne, you're stuck on the side of the road. How far are you from the house? If I was nearby, I'd close down the stream and come get you. Tara lives nearby. Mm-hmm. I know, I can't volunteer anybody like that. Uh-oh. See what she says? We need to see Daryl.
Another time, perhaps, Marianne.
Well, I think that's fine.
I look like death warmed over. It's one reason I don't do it. I used to be so pretty. Well,
you need to wear wear one of those one of those masks.
Yeah.
One of these days we should both just wear masks and come out with these masks on. Like, hey, folks, it's me. Who is that? Who is that masked man? Yeah, okay, so I'm just trying to sorry I'm on the same object over and over, guys, but I was borderline gonna stream tonight and not stream. I wanted to try and refine a few things going on. So we're looking at the same nebula and taking 2-minute exposures, trying to refine this system. So I'm going to keep refining. But the reward will vastly outweigh the negative side of this. Okay, and then this guy again, enter. And now we're going to say 13. Up from 10. And now let's see how this one comes out. You have to take a couple of those. Here's the thing. Bear with me, guys. We'll check out other things, I promise. Pool put you in blue light and me in red. That's a cop talking, you can tell. Blue and red lights. Next thing you know, she'll want to hear a siren. Oh. Stephen Root, you're a sound-alike. You see that, Daryl? Uh-oh.
Oops, what's that?
Oh, good. I thought your PC rebooted on its own.
No. Jesus.
Someone said Dalai says you're a Stephen Root sound-alike.
I don't know who Stephen Root is.
Well, look him up on Google. Because the truth is, I don't know who he is either, but I'm not going to say that. Oh, I just did. Tonight's a really good night. It's actually not bad considering the moon is out.
Well, he's an actor. American actor and voice actor. He has starred as Jimmy James on the TV show News Radio, Milton Wadhams in the film Office Space. I know about as much now as I did before.
Dalai says he's on Barry. Barry what? Barry who? I don't know. I don't know the show. Ooh, that's more promising. I think we have a little cloud in the way here. Okay, we'll do one more just to see if that's going to work, and then we can move on to other objects finally. Thank you. And the other thing we're going to do is bring up the all sky.
When I was young, people told me I looked like Richard Dreyfuss in Jaws.
Before or after the shark attack?
Before, hopefully. Well, he lived.
He did, I know. I was being funny. It's better than looking like Brody. Instead of, Roy Scheider.
Yep. Or Oliver Reed.
Yeah. That's Quint, right?
Yep.
Yeah. Yes. Quint had an issue with the shark. Okay, we're doing a 40-second exposure with the all-sky cam. We'll just see where the hell why is it doing that? Okay, I don't know why it did the gray, but let's see. That's all right. We should be taking a picture though. Maybe we're gonna do it. Okay. There we go. We'll see what it looks like. Okay, now let's go back to this. We're still in our 2-minute shot here. It looks like there's a little cloud bank that was passing over. There were some clouds coming, but we're not constrained to this area of the sky. I was just doing it because the moon was out, and I thought it might be nice to actually try to see how the sky looks with these filters. We're seeing some really nice detail. Okay. Yeah, it looks like we got some clouds and see this red haze there. Or that's the edge of the dome. Could be that too. Let's go back and look at the telescopic view here. Oh yeah, we could probably be getting an edge of the dome right here. See, right there. Probably getting clipped just a little bit. I just like to. I have no problem putting this in the. In other words, putting the red light on. I want the red light to be on so we can see what's going on. All right, let's get rid of this right now, and let's go see Should we check out and see if we can see Jupiter from here?
Sure, why not?
Okay. There go the stars.
Planets are good on moonlit nights.
Yep, they are. And we're going to... Which star right now? Aha, here it is. We're going to this star right here, which is Albalda. And then the Jupiterian, Jovian planets. All 4 Galilean moons visible to us. Telescope will settle down here in a moment. And we're going to drop the ISO down to 50. That way. Hey, where are you going? Ugh. Why does it do that? I have no idea why it did that.
Callisto, Ganymede, Io, and Europa from left to right.
Okay. I have no idea why it just did what it did, so I'm gonna tell it to go to Jupiter again. And let's see what happens this time, because these are glitches in the database that I'm digging out, you know. I must be the only one digging these things out, I tell you. I have to be. Let me go to this star right here.
Maybe the guy who typed in the coordinates was dyslexic or something.
I'll bet true that. Oh. Okay, so now it's going to that same star, okay? And that same star is Albalda, and then I want to go to this star over here. Oh, you can't see that. Hold on. And now... Okay, that's weird. I told it to go to... I told it to go to this star. And now it's going to Jupiter. Wow. Okay. And now we're taking off into the Never Never Land. Wow. That's just crazy. Alright, well, we'll fix that. Not a problem. Alright. Well, we saw Jupiter for a second. Okay. So clearly... sometimes planets do this. I don't understand that. Okay, so what we have to do is we are going to enter a faster mode, and I'm going to send us east with the telescope now. And now let's watch the screen and watch if Jupiter comes sailing in here. Oh wait, north. Yeah, I don't understand. But what I could do, actually, is pick, let's see, deep sky. You won't have Jupiter in there. It's okay. I can fix this, but it only happens on the planets, so for some reason I don't get that. Okay, so first things first, let's go back to our smaller movements. Okay, now what we'll do, now that we have Jupiter in here, we're going to get down here below. Well, let's actually go, let's do 15 seconds at 800. 1,000. I'll tell you why. And then we're going to revisit what you said earlier, Daryl, about which one was which. Okay. So this was Callisto out here?
Callisto, then Ganymede.
Ganymede.
Then
Io?
Io and Europa.
Europa. Okay. So 15 seconds at 1,000. This is the seconds, the timing, and then this is the ISO that we're looking at. Okay. Actually, we're using which filter right now? We're using filter number 2, I believe, the wider narrow band. Yeah. Okay. So let's increase that a little bit. Let's go back to our view, and let's go 30 seconds at. Let's go to 2,000. All right, 30 seconds at 2,000. Marianne, what happened to the trailer, your boat trailer? Tell us all the juicy details. What did your boat trailer do to you? Okay, so the point of taking this deeper shot is to look for, we're going to come here again, and it'll be pretty bright, see? But we're going to look deep in the image to see, are there any other moons that you know of, Daryl, in this? Maybe we can look. Let's do this. Let's just see if there's any others that are going to show up. Probably not. We're just seeing the Galilean moons.
Right. Jupiter's other moons are all tiny little things.
Yeah.
I don't know if you'd pick them up or not.
Well, most of them are. Okay, that's a star there. And where is that star? Is that one of these two? Or wait, no. Oh, no, not at all. That's going to be really close. That's going to be a star right in here, but it's probably lost in the glare. It's like right about here. Possibly lost in the glare. Okay, let's just try and take some shots of it to actually look pretty. See if we can get a nice pretty shot of it. So we're going to go down again to just 50 ASA. Why do I change this sensitivity? Well, and not just leave it at one basic one, because we're trying to save on the noise. The higher this number, the ISO, the sensitivity, you're pushing the chip sensor to push out more pixels. I'm sorry, photons, into the or capture more photons in the chip. And when you do that, it causes some problems, especially when it's time to look at and analyze these images. Okay, you're going to see some very bright objects and very dim objects, and let's see what we got here. Oh, it's interesting. It looks like we're out of focus just a tad. So let's go back and let's go into our focus view, and let's increase the brightness a little bit till we just see some rough moonage. Okay, and now let's bring this down and over. Go west, young man. Okay, now let's see if we can refine this focus. As the focus changes, you not only see Jupiter get blurry, but those moons sort of disappear. And we'll try that. just do this. Actually, we'll do it this way so we can actually see the moons.
May I make a suggestion when you're done focusing?
Sure.
You have a live video mode, don't you?
I do.
Try that.
Yeah,
Sometimes that can help when the seeing comes and goes. You get moments of great clarity.
Yeah.
And
we've done that before.
Often what planetary photographers do is they just do live video and then they stack good frames out of the stream.
Yeah. Now we use PIP to do that as well, and we take like 20 seconds worth of video and then stack all those frames as a separate photograph and throw out the bad ones and keep the good ones. It's really quite a good way to do it. But let's just take a photo and see what we got, and we'll try that anyway. No, it's better focus anyway, believe it or not. So at least we don't have the dome interfering. That's been a delayer all night because I've kept it on a 5-second delay. I don't need a 5-second delay. Oh, Dala, yeah, that's the cloudy night stream we did where we traveled to the planets and circled and orbited them, and that was basically dynamically using Space Engine to do that. Because in my professional career, I've taken people on journeys into the universe and whipped around planets and used special, skid around the planets while turning and facing the planets. And so it sort of becomes second nature because it's just so effective at making people just get sucked in. Imagine that in a big theater that's hemispherical. Okay, I did that at the studio with Doug Trumbull, and we had the Digistar system, which is the digital universe, and it's got 4 graphics processing units. It's got millions of stars that are all updating dynamically on the screen in front of you the whole time, and you can fly out to any of them. You could circle the Pleiades in space. The only thing that it didn't do that this thing does, that we used, is it actually can create a nebula, and you could fly through the Orion Nebula, for instance, with the Space Engine system, but not the Digistar system. So at the time anyway, we couldn't. So I'm not sure where they've come with that, but I'm hoping that they've gotten a little further along. All right, let's see here. Let's go drop it even more. Just 2 more stops. This will be dim, but this will be instant now. There we go. Oh, look at that. Is the red spot? Is that the red spot? Looks like it's in the wrong place. I don't know if you're talking, Daryl, or not. Yeah, that's not the red spot.
I'm looking.
Yeah. Yeah, see, it's not. Here's.
Red spot's not up right now.
Yeah. Oh, I see. We're seeing probably part of the that upper band. Looks like it has a widened area. Wow. Well, that's how big it is in the telescope right now, because we're not using any special magnification systems of any kind. So this is digital magnification here. Not bad. Okay. Right.
I know you talked about getting a dedicated astro camera earlier, except you had a swing through issue with your mount.
Yes.
It was making me wonder, though. I was reading something the other day about selecting cameras for astrophotography and pixel size.
Yes.
And whether DSLR or a dedicated astro camera, and if so, which one. And
yeah,
I gather one of those things, with planets in particular, is pixel size. They want smaller pixels to the sensor so you can see more detail on the planet. Where does the DSLR fall in that whole mix?
The DSLR, see when you talk about the cameras, you're actually looking at, when you talk about the pixel size, the pixels are measured in microns, and the camera we're using has a smaller pixel size, a smaller micron size per pixel than the astronomical cameras. But that's not to say that you're going to get worse pictures with the astronomical cameras, because it's in the way that the pictures are read out and then processed that the camera does specifically, and it's sort of like the science of imaging. And I can't say for sure what the camera pixels are that I was looking at, but they're different. And as far as my camera, I use the Sony A7S II on this telescope, and it performs very well. This is the camera that's going to go to Arizona, but I am going to experiment here with the remaining telescope. The remaining telescope here is actually going to be, SkyTour LiveStream, 1 again. It effectively, we're using SkyTour LiveStream West right now, because we're using all the equipment, all the telescope gear, and all the code that I wrote for the programming to program the whole observatory. But when it goes out west, everything out there goes. And then when I have an empty building, I'm going to consider putting in another roll-off roof building here and get rid of the dome, so that we'll never have to move a dome again. And as far as the camera question, I'm not sure how that's gonna play out, Daryl. I'm just not sure. I got to bring this up so we can actually see if there's a star. There's a star down there. Which star is it? Okay, did we already go to where we're going? Maybe we did. No, we didn't. It still says we're on Jupiter. That's not right. That's not right at all. So, where are you? Well, we did move just now. So now we're going to another star. And we're going to go to Albalda again. Okay, it looks like this is not updating. Well, let's see what the telescope's doing, because the telescope doesn't always have to listen to what this does. And that might be a good thing. In fact, I'm going to close this now because it's not updating.
I see your Skype chat's not updating either.
It isn't?
It's several minutes slow.
Really?
Yep.
Hey there, KDQ. Okay, well, let's go see what's going on. Well, it says I have an excellent connection. Are you saying that what you're looking at online is different from this?
Yes. KDQ said good evening, everyone, several minutes ago.
You're kidding.
Nope.
Wow. All right, well, let's see if we can fix that. Okay, well, we're going to get rid of that.
I've noticed YouTube chat does that sometimes for me. It'll lock up and I have to refresh the screen.
Okay, well, I just basically did that. So now let's see what we got going on here.
It looks like you're up to date now.
Okay. Okay, so that's done. Let's go and see if we have our wondrous cluster that I tried to capture here. I don't think we did, though, because this hasn't updated. So I'm going to kill this and start that up again. We'll see at the end of 20 seconds. Yeah, there it is. See, so the telescope's working like it should. That's one of your favorite globular clusters, but not the favorite globular cluster of Daryl Mason.
Must be M22.
You got it. It is.
Stellarium must be working now because that's where it says the scope is pointing.
Yeah.
Just above the lid of the teapot.
Yep. I had to kill Stellarium and start it up again.
Uh-huh.
Yeah, I've been trying to find workarounds for all the things that may go wrong with this system, you know? Yeah. Alright, 1 second. I have to try something else here now. Alright. Yeah, that's really... What? We label, go away. Yes, that's beautiful. So we're gonna go back. Now we are using a... we are definitely using a filter here, so that's a little bit problematic. But we need to do that because the moon is out. And we're using filter number 2, as you can see right up there. Okay, filter number 2 is the wider narrowband filter. So when we look at the whole spectrum, we're actually looking at swaths through the spectrum that are kind of wide. When we go to filter 1, on the other hand, we're looking at very narrow swaths through the whole spectrum. And that gives us the narrowband view, so less light pollution can get in, and only the data that's important, like that of the nebula. As an example, earlier tonight, as a matter of for testing, I was taking pictures of the Lagoon Nebula, and I took pictures. Okay, for instance, this one. This is a picture of the lagoon that I took earlier, and this was while the moon was literally not I don't know what 10 degrees away, maybe 20. And look at this, all this detail regardless, and then even longer exposure, you could see even more detail. And this is how these filters work. They're meant to do this beautiful work, you know. So that's the Lagoon Nebula that we took earlier tonight. And then we did some of Measure 22 here, and that's on its way toward looking. Well, the moon is still out, of course, so it's affecting it as well. But let's go in and do 30 seconds. No, 30 seconds at 4,000 on 5,000 on Measure 22. This is a beautiful globular cluster. Do you know offhand, Daryl, how many stars are in Measure 22? There's tens of thousands for sure.
Not offhand. Give me a second. I'll try to find out.
All right. Yeah, gas mask. You mentioned way earlier Proxima Centauri B closest. Well, it may not be Earth-like. It's actually far enough away from the star that it might not be habitable at all. But I get your point, and you're saying later they're looking for gases in the atmosphere like hydrocarbons, might suggest life. Well, actually, the James Webb Telescope, when it gets up there, is going to look in the atmosphere of many exoplanets, and it's going to look for carbon dioxide. It's going to look for other gases like methane and so forth. Because carbon dioxide and methane together, believe it or not, depending on their ratio, will say that will spell out the fact that there is oxygen in that atmosphere. We can't see oxygen directly because oxygen is actually in the visible spectrum, and the James Webb Telescope is an infrared telescope. But it is only going to get better for us, astronomically. Look at that. Isn't that pretty? Gosh, that's really pretty. Oh, yeah. The filter is coloring the stars a little bit beyond what they really are. We'll do another stop up.
The wiki on the M22 says Shapley counted 70,000 stars in the cluster back in 1930. I wouldn't be surprised if it's more now. It's about 10,000 light years away.
Yeah. That's
and
why.
Actually, if it was farther north, it would be as brighter than M13.
Yep. Wow. Okay, we got a little error in the guiding there, so I'm gonna take a shot to get us some good guiding. All right. Oh, I had started up this guy. Let's see what we got. Okay, we have the moon setting. We don't have dew yet, which is fantastic. And now I'm going to do a contrast, or a linear stretch, actually. Activate. Wonder Twin powers activate. Okay, we'll do that. Maybe just darken a little bit. Ah, look, even with the moon out, there's the Milky Way. I love it. Actually, it'd be better if you could see the whole thing. That's better, huh? If you saw my post on Facebook, I posted my world. I showed you that spherical image of the house with the observatory in it. That was kind of cool. All right, that worked. Luckily, there's no clouds. That's fantastic. We had some light ones and they went away. Okay. The moon is setting too, which is even better news. Let's see what we got here for this now. Oh yeah, that came out pretty. Look at that. Let's bring that up for all of you. Yeah, that's right, Gas Mask. It's definitely going to be a eye-opener. And you know, it's going to teach us a few things, and it's probably going to change some science. Because we don't know of any other life other than here. We suspect. The galaxy and is full of life-bearing materials. I can't believe there's only one planet here that has life. I mean, you could say it as a pessimistic view, but I'm not a pessimist. I'm actually more of a realist. And realistically, it's very possible that there is other life forms out there that we just have not seen, clearly. And I think that makes a lot of sense. And I think that we should be looking for such. One place we can look is in clusters of stars too, especially the older ones. Okay, let's go to NGC 6647 here. Okay, this is a cluster that's well, it's probably pretty faint, about 6645. I won't try it. Let's go to one or the other. Let's go now. All right, and I'll tell you why. Okay, so we're going now, and we're going to head over. There we go. We're doing the precision pointing to one of the stars here that's important for us. Which star is it that we're going to? We're going to Caus Borealis down there. where it's actually right there. And then we're going to head north. Alright, once it's centered up, it's then going to go racing away and take us up to the spot. There it goes, to where we know we're going. And that is right up NGC 6645. Alright. And so I suspect that NGC 6645 is right here. But we should find out, shouldn't we? Yeah, now I also put up our field of view. Yeah. Okay. So let's just take a 20-second shot here at 6400. Hey there, Papa Tom. Hey Keith, how you doing? Table of contents in the description, Keith. I have to put all the table of contents in because I can't get YouTube to allow me to generate a table of contents. You used to be able to do that, actually. Wow, this is really pretty. Look at this gorgeous cluster right here. The other night we looked at carbon stars, which are really, 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 really red. Blood red. Those are phenomenal stars. Dredging up carbon in their interior and then propelling it outwards into the outer envelope of the star. And that carbon actually, because the stars are so big, they're cooler on the outside, and the carbon can actually make molecules and condense into dust. And when we see that dust, it actually reddens the starlight tremendously. Just like a fire reddens the sunset even more, as people know in Arizona and California. So, really interesting. This is a beautiful cluster, though.
It looks almost like a halo of stars in the middle.
These here? Or are these?
In the middle of the cluster, to your right there. Looks like a circle of stars.
Oh, right
almost.
Here. Well, a circle of stars or absence of something, huh?
Yeah.
Yeah, that's true. That's right. Definitely. Okay.
Funny what you see.
Yeah.
I remember when we looked at the Tom Thumb cluster, I thought that was Tom Thumb over there waving his hat at everybody.
That's true.
Looked like a little man tipping his hat.
It did, didn't it? All right, let's see if we can find something nearby as well. We can go down to that guy, but I think I want to try looking at another nebula like this one. You go to the Omega. We'll also hit M11, I hope, on the way up. What do you think?
Sure.
Yeah, M11 is just a real nice one. For those who joined SkyTour LiveStream after watching our introductory video, this is the song that I used for that. Okay. And that should be the Omega Nebula. Okay, let's see if it is. I have to wait about 11 seconds for the guider to catch it. Let's do it this way. So it's right there. And we know where we are, so get rid of that. Okay, and then we're going to go west a little bit. And what Daryl was saying before was I could go into the the video mode here and increase the sensitivity dynamically here to see the nebula. But it's up there, but we've got looks like dome in the way at this point. So it's a good thing we checked. We'll actually do 12,800 and then we'll see probably 30 seconds, but I have to move the dome first. Can you cover me, Daryl?
Sure.
All right. Oh, and Keith, thank you for telling me about uploading to astroimaginglive.com, which is where you can find P&K Space Imaging, SkyTour LiveStream, and Bill New York Skywatcher all in one place. And you could click on, if they're all active at one time, you can actually go in and out of each of our streams and check it out. But there's a gallery up there of imagery that I have not been updating as much as I should. And I just did a big Facebook post with some of our latest imagery on SkyTour LiveStream. But I have to put those on astroimaginglive.com. So I need to do that. And I just don't know how to do that. I have to go back and find all the login credentials again. Anyway, I'll be right back. I gotta go move the dome.
Okie dokie.
Thank you, Daryl.
Mm-hmm. Folks, I have a question while Mark's gone. Question for chat. Did anybody get a notification tonight? Did y'all just happen to come by, or did you get an email notification? I know it's been said that YouTube is doing away with them. I just wondered, looks like the room count is down quite a bit tonight. Hello, Martian Johansson. Mark is streaming the music from his library, I guess. It's still very smoky here from the fires here in Colorado, plus the fires from California. The smoke from them is overlaying our smoke. Been really hazy and smoky here. It's pretty foul outside. The moon, for me, when I watched it set recent evenings, is just blood red. Very eerie looking. I went out to check the mail late yesterday afternoon, and there were storms coming over the edge of the mountains, but they were petering out as soon as they cleared the mountains because so hot, humidity so low here. The sky was really eerie looking with all the smoke. I saw the coolest thing though. I looked up and there was a hawk soaring in a pretty strong breeze. He was hovering right over my head. And it was amazing. I watched the guy for several minutes. He moved around a little bit at a time. You'd see him just barely change his wingtips to navigate, around the neighborhood and stuff. It was so cool to watch.
Wow.
His wingtip feathers, whatchamacallem. You could see the guy, he'd just, alter the spread of his wingtips or tip them up or down a little bit, and he'd move over some. He was looking for prey down on the ground, of course.
Mm-hmm.
Welcome back, Mark.
Thanks. A lot of thermals.
Uh-huh.
Okay, yeah, this is the Omega Nebula. This nebula is really interesting because for the longest time there were stars being made in this nebula, and because most of these nebulae are all H2 regions where star formation is carried on, and usually you can tell when you look in there, you can see it's like some new young clusters and stuff. But in Omega Nebula, you notice you don't see young clusters. We just see some smattering of stars. We see a dark area here. This is actually a dark material, as opposed to a gap in the material. It's dark material that's overlaying a nebula behind it. And of course, out there you can see nebula also, and over there and down below. So this is a nebula that's in decline, actually, and they're eventually, when the stars that are causing it the gas to glow, when they finally move away or settle down later in their lives, this area of space will no longer glow. So I think it's going to be pretty interesting. Hey Martian, how are you? Nice to see you.
Martian asks where you get your music from.
The music is actually royalty-free music, and we get it from, actually YouTube has a whole selection. And some of the music that we have is actually classical music that you can hear, and that's also free as well. So I just think that, I picked the ambient tracks for doing this because I don't want anything that's going to compete with Daryl and I or Amanda talking. Amanda said she might join us, but I don't think she's going to make it. I'm just guessing. I don't know for sure, but I told her to show up in the chat.
I wish she would.
I know, because everything's better with
Amanda.
Yeah. That's exactly right. Okay, so let's go back now and do one more photo. Let's do a 1 minute, or just a 2 minute. Well, this might be a 2 minute shot. Let's find out. Let's go see what we're doing. Okay, this is a 2 solid minute shot. We'll try that. Sometimes when we move, it works to our advantage. What's our sky look like? Okay, this is our sky now. Yeah. Okay, you can see our Milky Way right here. Daryl pointed this out the other night. This dark area right here. This is actually the Great Rift in our Milky Way, as he pointed out. This is just, these two things are just lens flares from the moon down here, which is low to the horizon. I'm thinking we're going to head up into Cygnus after, maybe into Cassiopeia once it comes up a little higher, Daryl.
Cool.
Yeah.
The Great Rift there,
That's this right
if
here.
you're under a good dark sky where you can see the Milky Way, if you look from Deneb and Cygnus running down toward Sagittarius, you'll see this big dark rift that kind of splits the Milky Way into. That's a big, huge dust cloud and a spiral arm.
Yep.
Dust clouds, probably.
Oh, for sure. The result of billions of years of star birth and star death. So, really, really amazing. Are we still doing? Yeah, we're still doing a 2 minute shot here. So we'll see how that looks here in a minute. For moonlit night, guys, I guess it's hard to really tell, but for moonlit night, this is really a really excellent showing. Oh, it's actually too long, and I'm gonna take us down to a minute on these. Okay, and then I'm going to take us over to filter number 1, which is the narrow band filter, and we'll leave it on bulb. That's the 1 minute shot at 16,000 ISO, and we should have our guide star, and away we go. Ronald is here. Hey, Rascally Rabbit, how are you?
Mark, would you excuse me for a moment, please?
Absolutely.
Be right back.
I'll be right here. So tonight we're just fumbling through the Milky Way and looking at some objects. While you're waiting, I'll just show you not this guy, but this is the one we just took of that. And earlier in the evening, I took some photos of the moon, which look really pretty. Gosh, that's we're not too big of fans of the moon, right? But it does have some beautiful detail on it. Oh, and then there's this. Wow, look at that 1 minute shot with this really special filter. That's really pretty. Yeah. Now you see these little speckles all over the place. These little speckles, these are noise. But that's not a problem. I can get rid of the noise. Here's an example of a partial way to do it dynamically. Okay, so you compare this, okay, to this. This is a little bit denoised, and that's pretty. Okay, that's the nebula I was telling you about, where it looks like, for the most part, star formation may have stopped or is on the wane. Because normally with these beautiful nebulae like this, we would actually see a young cluster inside of them. Where do we see that? Well, we see that in the Lagoon Nebula, for instance. We can show you that by just heading down to, or over to, the Lagoon Nebula. Just do that real fast. So here we go. We're going to the Lagoon. Heading to the Lagoon. And we're going to pick a star to align with. And that's going to be pretty low in the sky, actually. And is that going to be... Yeah, Al-Nazi again. Okay. And then from there, we're going to go right up to the Lagoon Nebula here. And this image actually is actually not as good as we do. We can actually take better images of it. So we should see now. Yeah. And I'll just quickly grab the through the view. So this kind of show you, this is a straight look through the camera without any filters in front. So I removed the filters. Alright, so now we're centered right on the Lagoon Nebula. So now I will put the filter back in place. Okay, this is our narrowband filter. If I took the same shot for the same seconds with the just looking straight through with no filter, we would get a very, very bright sky and very, very little nebulous detail. Okay, so this will be 1 minute at 16,000. We should have our guide star by now. I'll just wait a couple more seconds. And there we go. Heading to the Lagoon on the midnight special. Yeah, it's kind of funny. It's like, we be heading to the Lagoon. That's right. We're going to the Lagoon Nebula. See you there. Could almost make songs out of this, you know. Pretty cool. So now, with the bright moonlight, it's going to be kind of hard for you to judge because I didn't take any white light shots. But you're going to see the lagoon now here, and hopefully it came out pretty good if I let it get a guide star long enough. And we're going to find out in about 3 seconds here. And I'll tell you what it's going to look like. Hopefully it's going to be perfect. Yeah, look at that. That's beautiful. That came out really nice. Wow. So on a moonlit night, we can still take pictures of nebulae. I have wanted to do this for the longest time. Let me just process away some of the noise. There we go. Now you see it like it is. This really came out nice. So what are we seeing here? As I said before, we have a cluster. This cluster of stars is clearly a young cluster, and this young cluster is systemic to the fact that and it's systemic to and endemic to these types of clusters where they're still active, a type of nebula where they're still actively producing stars, and that's what we're seeing here. Still producing lots and lots of stars. And over here we see this little guy right here. See that little hourglass shape? Well, you can't too easily, but let me zoom in a little bit. Okay. All right. So this hourglass shape right here is an area which is being caused to glow by a bright star here. This star is actually an O-type star, which is a extremely hot blue star. Most of the radiation from the stars that are O-type stars, which are the hottest and bluest of all the stars, is in the ultraviolet. Okay, so welcome back, Daryl. So when we look at,
thank you.
Sure. So this area right here is being made to glow by this bright O-type star. And if you remember our spectral classes, we had O, B, A, F, G, K, M, and those spectral classes each have a 0 through 9 distinction within them. So an O2 star is a lot brighter and bluer than an O9. Not by much, but enough. But usually it's the measure of the amount of ultraviolet light coming out. And so we know that in an area like this, and this whole region actually all around this in this nebula, it's probably not going to be an area that's conducive to life in general, because it's such a hot location for life to try and thrive, when we know that that ultraviolet radiation can disassemble molecules that are required to foment the formation of life. Okay. Also over here we have these beautiful dark lanes. Okay, and I like when we look at these dark lanes, what we're really seeing is the dust that has littered this area of space from previous explosions of stars all around it. And so you like that snaky dark nebula up there, and this bright little dark little snaky line right there. These are areas where there's thick dust that formed at one point in the outer atmospheres of stars that were dying, and they moved to red giant stage. Not too far from here is Antares, the Eye of the Scorpion, and it's a red supergiant star. Its outer atmosphere could possibly have, and does have actually, molecules in it. So these molecules are composed of, among other things, a lot of the elements that the star had been made with when it first was made. Okay, but it also builds its own in the core. But those ones in the core don't get out until the star goes supernova. And Antares will one day go supernova. Just like Betelgeuse. There was a question in the chat earlier tonight, which I forgot to talk about. Betelgeuse is dimming again. We talked about it on Radio Show Sunday. And this dimming of Betelgeuse looks like the result of a outburst from the star's outer layers. But again, as they expanded off the star, they cooled. And the compounds, then the molecules that were formed out there, actually began to condense into dust. And that dust obscured Betelgeuse. That's what we think anyway. Are we wrong? Maybe. Are we right? Possibly. So you see, we are kind of inexact. This, Daryl, when you were away, I actually took this picture of the Lagoon. Yeah, and this was with the very narrow band filter. That's not bad. I showed it as an active stellar nursery, whereas the when we looked at this guy, the Omega Nebula, you don't see an active cluster here. So we know that this is probably done doing star formation for now. But this guy, on the other hand, he's still active because there's a beautiful hot cluster. So, and that's very important to notice in these things. Let's see now. We're going to go back to the trifid one more time and I'll tell you why. Because I actually don't have to do anything but steer us there, because we know where to go from here. I don't have to go through the whole auto finding process with this. So we're going to go up to here. This is going to give us a little more. So we're going to go up a little bit.
Mark, Ronald asked a question.
About dark matter?
Presumably, yes.
What did he ask?
Is all dark matter dust? In the context of you talking about the dark clouds or the dark nebulas,
Yes.
Does he mean capital D dark, capital M matter, or just dark matter?
I think he probably means dark matter is what he has heard in the literature, in the stories online and stuff. So dark matter, namely being that is not presumably just matter that's dark in color. I think he means dark matter as in the classical definition that we've all been hearing about dark matter. That's my thought. Ronald, to answer the question, we don't know because we can't see it yet. Now, it could mean that that's because dark matter is truly actually dark, but it could also mean that dark matter is something else entirely, or a misunderstanding entirely of how we're interpreting what we're seeing. That's possible too. What am I doing here? Oh yes, now I know. I have to, I'm gonna quickly go over to our through the camera view here, so we'll see more stars. And these two stars close together constitute the Trifid Nebula, so I can bring it in. Let's go and do this and this. Slow us down, and let's head west, shall we? Yeah. And then we'll head north a little bit. There we are. And now we will go back to our filter number 1. Okay, Trifid is probably how close to the horizon right now? Let's see. Oh, we're actually okay. Not bad. We're in the southwest, but it's not that bad. We could tell by the angle of our box here. That's the angle the telescope is looking over at it. Okay, so let's go and take another image of it, and that image is going to be 1 minute at 16,000, and this should presumably be better than it was. First things first, let's do this and do this. Okay, image underway. And now, so we have gone actually in terms of where the Trifid Nebula is from this, it's that way. It's right up there. I'm just gonna head right up there, above the nebula, way up here somewhere. Just very, very close to it. So there's actually, with the other telescope, the f6.3, which is a slightly wider field, we can actually have, at the top of the field, we can have the Trifid Nebula, and at the bottom of the field, we can have part of the Lagoon, which is kind of nice. But I prefer this view because it's a much more much closer, much more magnified view than the f6.3. This is f8.
Greater focal length.
Yes, sir. Hey there, Go Captain America. What's up? Oh yeah, look at that. Let's zoom in on that for a minute. Yeah, that looks nice. And now let's process away some of that speckle noise. Oh yeah. Look at that. That's gorgeous. That looks pretty. You can see the blue. The Trifid has actually got two components. It's got this beautiful red nebula that's broken apart into 3 distinct sections by dark lanes of dust in the nebula that are blocking the nebula behind it. And then right above it is another nebula, which actually is blue, and you can barely see it. It's there, and there's a lot of that information is here in this image. Let's see if we can just go up one more stop to 20,000, take another minute shot. All right, but the Trifid is actually one of these places where, again, we know it's active because we can see these 2 bright stars in here that are probably doing their fair share of the work. And I want to introduce you to something else. There's an online database that you can use to look for almost any star that you may know about or think about, and it's called Sinbad. That's not Sinbad the Sailor as in S-I-N-B-A-D, but S-I-M as in, S-I Mike, and S-I-M as in Mike, B-A-D, Sinbad. And when you go to Sinbad, you can do what's called a basic search and look for anything, and you can see what's going on, and see these stars and see them in the nebulae that they inhabit. If you're interested, oh cripe, a little bit of a problem there. Deleted. Deleted. Okay, we'll do that again. And if you go back to Sinbad and you look at any star you want, you can actually see things like specific stars that we talk about that might be things called Wolf-Rayet stars. And in the Crescent Nebula, which we took one night, and which I also included in that amazing image that we took here, which is wonderful, and put it up on the Facebook post. You can actually see the star that's actually blowing all this stellar wind out at very, very high speeds and very high temperatures. And I think you'll appreciate seeing that. Hey there, Rachel. How are you? Yeah. I'm reading Marianne's comment. Still waiting for a tow truck? Marianne, if I was out there, I'd put everything aside and come out and help you. I don't think that's healthy to be stuck on the side of the road. At least it's not as hot as it's been. Okay, I'm just trying to see what's going on here. Well, Marianne is humble there, Tara. Oh, Mizar, huh? Well, I'll show you where Mizar is, Martian. Martian's asking if we can look at Mizar, asking if that's a favorite star. But if we zoom out a little bit here, all right, Mizar is over in the Big Dipper, all right, and if you notice, it's way, way down there, and it's right here, and I don't know that we're going to be able to actually see it. It's a really pretty star. I will show you my favorite star though later, and that's Albireo. I talk about that in the post tonight too. There we go. That's a nice view of the Trifid Nebula. Yeah. So Mizar is it's a little too low. See, it's actually about as low as this. This is, you know, we're looking now at something that's only what, 15 degrees above the horizon now. So we really need to start climbing up a little bit. We're gonna climb up to the Eagle Nebula now, and then we'll go find another couple clusters, and then we're gonna head up into the Cygnus Milky Way, and we're gonna check out some beautiful star fields in Cygnus. If you notice, okay, right overhead, almost directly overhead, is the North America Nebula. We've got to take pictures of that again, don't you think, Daryl? I mean, it's almost right overhead. And when things are right overhead, that's the best place for them to be.
Yeah, if the moon's not a problem.
Well, with the filters we're using, I don't think it will.
Okay.
If I get your drift, Marianne never goes unstrapped.
Good. A lot of desert rats out there.
Yeah, there really are. And you need snake shot too. You know what I mean?
Oh yeah.
Okay, so we're doing a 1 minute shot here of the Eagle Nebula with our narrowband filter. And let's go see it. Oh, I guess it didn't. Oh, I didn't take the shot yet. I was just waiting for the telescope to get there. Okay. Sorry, my mistake. My mistake. Oh, yes. Okay, let's do this. Let's pull out here and see where we are. Yeah. Yeah, I made the mistake of just... Okay. Okay, so we should be over here. Let me go down to remove the filter for a second. See what we got. Oh, went the wrong way. It's there. Okay. And we'll just go here just to show you. So looking through, we can see it. All right. So I'm actually gonna go like this. Drop it down a little. Again, active star cluster. Ronald, you should go out to Arizona and you can be Marianne's stun gun for her. Ronald is also known as Robin Williams 2. I'll let him tell you why. Okay, we're going to take this picture here. And this is a 1 minute shot at 20,000 ISO. And we're actually looking down around here right now. Actually, no, we're not. Where are we? We're actually about here, I believe. Because I think these are stars of Sagittarius right here. So we're kind of up here. I think. I gotta get my bearings with this camera. That's okay. Besides, you couldn't see the whole thing anyway because I didn't have you in the right spot. Ah, Terrell, look at that. Wow. Let's get rid of some stuff. Okay, now this is where the moon, folks. Now this is really pretty. Really pretty. We're seeing a lot of detail in this. Let's just take some more. 20,000. Take a few more. Wow. Now, those of you who look at this, it may look familiar to you. The Hubble image, these are standing straight up. and these are called the pillars of creation. What they are some gravitationally condensed areas in this nebula, and the light and the radiation from the star cluster is dissipating the nebula, but not around the gravitationally condensed areas. And in the wake of them, the lee side of those, the material stays there. So if you imagine a wind blowing at these things, the gas is getting blown away, but here where the gas is clumped, on the backside, it's protected somewhat by their clump. So we're getting a lot of this stellar wind going down this way. That's my understanding of how this is working right now. And here is another shot to show you. That looks pretty good. Oh gosh, this is so amazing. I'll take another, and then I'm gonna head to something else. So I just want to have a few to stack for you. All right, Marianne, good. Her ride is there. I'm glad we could help her pass the time. Oh, yeah. I have to tell you guys, and maybe this is true for you, Daryl, I'm not sure. Sometimes when you see something beautiful in the eyepiece or in the camera like here, you just find yourself staring at it and staring at it and staring at it. And every time you look at it anew, you find something different. You know?
Sure.
Yeah. And these are just absolutely stunning. Absolutely stunning.
Oh, there are some objects. Orion comes to mind that.
Oh yeah.
I'll just leave the scope parked there for an hour.
Right? Yeah, and there's no reason not to. I mean, it's like you have every reason in the world to just soak it up. You know?
Yep.
I'm gonna go to the not quite narrow band filter and take a 1 minute of that as well. This is a record of our previous shots you can see here. We're going all the way back to the beginning of the night. Jupiter. Okay. And the Trifid Nebula. Lagoon before that again. And then the moon earlier. So I went from there all the way down to that. Or that. Pretty cool. This is an active H2 region, that is to say a stellar nursery. You can see a young cluster that's formed in here, and again, a lot of radiation being spewed by these stars, a lot of ultraviolet, and it tends to push away a lot of the material, you know, and it leaves these things to look like this. All right, let me just, wow, look at that. You can actually see a lot of detail in here, Daryl. Look at this. Wow. That's really pretty. That's just beautiful. I mean, you can see it here too, and the narrowband's going to really accentuate that stuff. But I think a few photos like this will go a long way toward allowing us to see even more detail in this nebula.
Ronald has a question. May I answer him?
Sure. Read the question, though, so people hear.
I have two kinds of eyepieces. Which is better, the one that has the bigger exit for the eye or the smaller exit for the eye? If by exit for the eye, if you mean the lens diameter, Ronald, typically they're going to be two different focal length eyepieces, and the larger diameter lens will be the larger diameter lens will be the greater focal length. Now, what that means is You divide the focal length of the telescope by the focal length of the eyepiece. That yields the magnification of the eyepiece, okay? So what you call the bigger exit for the eye appears to be a wider field of view. Yes, that would be the case because it'd be a lower power eyepiece. Yes, 32 or 9 millimeter. The 32 millimeter I would call a medium, leaning toward low power, and the 9 millimeter will be more like a medium to a high power, depending on the focal length of your telescope.
And whenever you use a high power eyepiece, you're going to notice the image is going to be a little dimmer, and it may not focus as well as you would like it to, and that's of course because many times telescope makers will say you can see 500 power with this telescope, and then you proceed to try that, and while technically you can see 500 power, it's not usually a very good view because the glass is not very well made on some of these generic scopes.
Those are Walmart telescopes. A decent telescope might give you 50 power per inch of magnification. 50 power per inch of aperture. That is, an 8-inch telescope might give you 8 times 50, 400 power, I guess, and that's really pushing it. The kind of telescopes Mark is talking about, those are typically little 60 millimeter refractors, which is about 2 1/4 inches.
Yeah.
And the highest I would expect such a telescope to perform, even if it had really good optics in it, would be maybe 120 to 150 power.
Right. Yeah.
Useful magnification. Anything greater than that is called empty magnification.
And the words useful magnification, very important that Daryl just told you. That useful magnification is literally what you could actually expect with reasonable view in your telescope. But what he said about the empty magnification, I mean, let's face it, if you see an ad that says 400 power and it's a little dinky looking scope, walk away. Or call one of us for help.
He has a follow-on. What would be the best to use for, like, say, Jupiter? Start with the lower power eyepiece, Ronald, and check out the view. If it looks steady, then try the higher power eyepiece. Planets are often looked at with higher powers, 150 and up, 150 power. When I say magnifies, that is, it makes the naked eye view look like if you're getting 50 power magnification, x50, it looks 50 times closer than what it would look like to the naked eye.
That's right. So if it was
now, there
50
are some
light years
exceptions
away,
to that rule of 50 to 60 power per inch of aperture. Some very high quality refractor telescopes, I'm talking apochromatic refractors here, that cost thousands upon thousands of dollars. Some of those
Very
can
expensive.
push 100 power per inch of aperture on good nights. A lot depends on your local weather conditions and what we call seeing, how still the air is or how turbulent the air is.
Yeah, like tonight, the seeing is good, but the transparency is less. Meaning, there's a lot of moisture and water vapor in the air, and that kind of limits what we can see. The filters cut a lot of it away, but not all of it. But the seeing is good, meaning the star images are steady. See, we can see little tiny stars in this view. Those would be lost on a night with bad seeing, or they would be kind of like not round. They would be sort of geometrically shaped or elongated in various directions. But we don't see that tonight, and so the seeing is good, but the transparency is kind of low. In the desert scope location, the seeing is usually very high. We rate it from like 1 to 5. The seeing is always on clear nights, which are about 300 nights a year, the seeing averages between 3 and 4.5, and the transparency averages between 3 and 4.5. as well on most of the clear nights there. Because,
excuse me.
Yeah, that's no problem. Because, and I found something else out too. Our location is sort of magic, because where the telescope is going to be out there, the nearby city of Wickenburg, Arizona. I say city. All the cities in Arizona that are near any type of astronomical facilities are constrained by law to maintain a dark sky as best as possible. And so the city of Wickenburg, you can't even see the lights of Wickenburg at our observatory location because, we have, of course, University of Arizona in various spots, and they, of course, constrain the cities to put all this downturned lighting called a full cutoff, and that doesn't let any light go out horizontally that can then go out and up into the sky and illuminate the sky. There's none of that. And so it's kind of a weird thing to go out there and see only streetlights that are lighting the ground, okay? I mean, we have that here now in Connecticut because we're a dark sky state, believe it or not. But out there where the telescope's going to be, we have a dark sky, and only to the east we have the light dome of Phoenix that's encroaches. It goes up about 25 degrees in the sky. Higher on nights where there's actually water vapor in the sky. It's actually kind of rare that there's water vapor up in the sky. Too much, to be honest. But it's really quite interesting to see the skies out there. I mean, I think I showed you pictures. I won't do it tonight, but I showed you pictures that I took on the flat slab. The first astronomical pictures taken at SkyTour LiveStream West was on the open flat slab before the building was ever built, or has been ever built. And I put a star tracker with my camera on there, and I literally took pictures until I couldn't take pictures anymore, until I practically dropped. What a beautiful night. And I could see, for instance, the Horsehead Nebula is notoriously hard to see in Orion. Well, I saw it in a 30-second exposure without any problem. Okay. So that was really impressive. So as far as, that telescope location goes, impressive. Most impressive. Maybe you'll be a Jedi yet. It's a gorgeous location. And I can't wait to take all of you there. I just can't. I think you'll appreciate it. Daryl, open invitation for you, obviously, if you want to make the trip out and check it out. There's room for you to set up a telescope in there to actually put up on a tripod. You can set it up and enjoy the benefits of the protected environment as well.
Oh, golly, thanks.
Sure.
Could I expand just a little bit on what Ronald asked?
You may.
Ronald, I don't know the specs of your telescope offhand. You say it's an 8-inch Celestron HD Edge. I assume it is an f10 telescope. You might look on the tube itself. It may say somewhere what your focal length is. Otherwise, it's probably in your documentation someplace. If it's an 8-inch f10, it has a 200 millimeter aperture, actually probably 203, and if it's an f10, your focal length is going to be 2,000 millimeters or so. Write that number down on an index card up in the top left corner, and then across the top, write the focal length of your different eyepieces. Like right now you have a 32 and a 9. You can also do this in Excel or something like that if you're so inclined on the computer. Just divide the focal length of the objective by the focal length of the eyepiece. That is your magnification for each eyepiece. Write those numbers down and keep that with your telescope. It's a ready reference so you can tell what power you're working at. If you continue in this hobby, you will tend to accumulate more eyepieces of various focal lengths for different purposes, like looking at planets or, higher power for looking at planets, or lower power, wider field for looking at deep sky stuff. And add all those to your database or to your index card, and it will tell you in an instant what your magnification is.
That's good advice there, Ronald. So I would listen to the man who has mastered telescopes and built them on his own. Okay.
2300 millimeters focal length. Goodness, that's getting up there. Okay, yeah, we'll do that then, and that will give you a good idea, a good starting point. I have eyepieces anywhere from 55 millimeters on the big end going down to single digits on the small end. And those are pretty much dedicated planetary eyepieces. I use the larger focal lengths to see wide field views, deep sky stuff, things like that.
I also had to ask Ronald a question. When you buy a telescope, they very rarely come with a 2-inch eyepiece. Usually it's 1 1/4 standard. So you probably have a 1 1/4 diagonal and 1 1/4 eyepieces or two. They probably give you 2 eyepieces, a low number one and a high number one, like you said. When I got the Meade, I got a 32 millimeter Plössl, it's called, and then I got a 12 millimeter for like looking at planets and so forth. But you know, the eyepieces you typically get with a telescope like that, unless it's a very special telescope, you don't get really the best quality. If you really want the best quality, then you have to go to a larger diameter eyepiece. And like the 1 1/4 is a tiny little thing like this, but then you get a 2-inch and it has a big giant barrel. And that's a lot of glass. I mean, the eyepieces can be pretty heavy. Daryl has one, what'd you say, 5 pounds?
No, it's a Televue Nagler 31 millimeter. It's a specialty eyepiece. It weighs over 2 pounds.
Oh,
it looks
2
like
pounds.
a hand grenade, and that's what I call it. The thing is humongous.
Yeah, I like that. I
And
have a hand grenade
it's-
out in the observatory that I haven't used in since I put the camera on.
Yeah,
It's not that not that though.
paid a lot of money for it too.
Yeah.
You don't have to, go off the deep end unless you're rich. But yeah, it's worth it to invest in better quality eyepieces. That'll give you more clarity, wider field, crisp to the edge, no flaws, optical flaws,
Yeah.
stuff like that.
Yeah. And the eyepieces in that 2-inch format, some, and I'm not really fully exaggerating here. Some of them have such a large, lens at the top. Okay, you could almost use 2 eyes to look into it. Not really, but you almost can do that because they're so big. I've actually viewed and seen eyepieces that actually, and I guess that you have to do that that apparent diameter calculation, Daryl. The angle.
Yes.
And but I haven't. I have to say I haven't used eyepieces in so long. And Daryl says he's a bad astronomer sometimes for not using his telescope. Well, I'm a bad astronomer for not keeping track of the eyepieces I have. I have several cases full of all kinds of different eyepieces. But that's back when we used to use eyepieces only. Once I got the bug to start doing this type of thing that you're all sharing with us, with Daryl and I mean, once I got that bug, I put the eyepieces away and I haven't looked back. And Daryl has expressed his disapproval with me for not using the eyepieces more, and he's right. I mean, you don't want to lose that feeling of looking in a telescope through the eyepiece. I have a childhood friend who's an astronomy buff, and I chose the path of going into astronomy, and he chose the path of going down the art path, and he lives in Tennessee, and he comes up sometimes during the summers. And when I told him how I have the setup in the observatory, I mean, to me, it's so impressive. I got all this camera work and all this camera stuff going on. And he's like, well, do you have any eyepieces? And I literally said without thinking, what for? And then I realized, wow, Of course, what for? I mean, because that's what people who enjoy astronomy like to do. That's what the appeal. The first view through that eyepiece. You know, yes, it's gonna not be nearly as bright as in the camera view, but you're gonna see it with your own eyes. You know, and there's merit to that. You know, and so Daryl's a classic astronomer. I'm more of a geek astronomer, I guess. I don't know what to say of myself, but I have nothing to say for myself. You know, because this is getting better and better, actually. I don't know what to say other than I know that I probably ought to consider using an eyepiece once in a while. There, I said
Yep.
it.
Yep.
Daryl agrees. I know. It is what it is.
Martian and I have several cases.
Without a doubt. Without a doubt.
I have one case. It's nothing but planetary eyepieces. They're high quality orthoscopics I got years and years ago, which are a relatively narrow field of view, but they have very crisp views. I've got wide field eyepieces. I've got medium eyepieces. I have one double set of eyepieces for the binocular telescope.
Yeah, that's fantastic.
And I have another set for a binocular viewer. Those are actually microscope eyepieces.
Wow. By the way, I just want to say hi to Bob Harless, who's here. Hey, Bob. And to Canada Boy, C&D, how you doing? Thank you for coming to watch the stream tonight. We're viewing the Summer Nebulae again, and actually, I'm gonna be making this into a final object here. There's a lot of, look at this detail out here. Wow. And earlier I spent time taking some photos of it in the narrow band, which looks like this. And we'll go back to taking some more of those too in a minute. Whew, boy, this is looking pretty tonight. Yep. Now that I've tuned the guider, it's actually pretty nice. Sure thing, Bob. Yeah, actually, that's a good question. With the f6.3, the other telescope we had, the moon just barely fit top to bottom. The full moon would just barely fit top to bottom in the camera view, the prime focus it's called, without an eyepiece. And so with the eyepiece, you get a more magnified view. Wow, this is just actually not a bad night overall, Daryl.
I'm surprised
Me too.
how good it's been with the moon and everything.
Yeah, well, the filters do the job, right?
Yeah.
Let's see, 1, 2, 3, 4, 5.
The skies are still
6,
crap
7,
here with the forest fires.
8. Oh, of course, huh? 9. Okay, and then a bunch of those. Okay, we got enough of those to give us something. Now I'm going to go back to the narrow band and get some more narrow band shots. Okay, now let's go back to our let's see, 20,000. Yeah, I'll leave it at 20,000. Now, you can't see any stars in the view, and you say, well, how can that possibly get a better view than this? You know, because the other one showed more stars, right? That's true. But you have to understand that this is only admitting light of certain wavelengths. The wavelengths, in fact, that are the red in here are being allowed through. The wavelengths that make this blue background sky are being rejected almost entirely, not quite. And you'll see some of the stars. Some of the fainter stars, though, you may not see directly, because the filter is made to see the nebula and the details in the nebula. Oh, thank you, Katie Q. But I'm afraid that the beauty is all the universes. But still, I mean, when you look at this nebula here, I mean, it's just, look at that. I mean, this stuff in here, these are the pillars of creation that Hubble took pictures of right here, right there. Those are the pillars of creation, and those are really beautiful. And of course, I can instantly process a little bit right there to kind of show you how it's going to look without the noise. I can do even better than that when we're done. What I'd like to do, though, is see if I can tease that time up just a hair. So we got 1 minute. Let's do 1 minute 30. Let's see if we can do that. 1 minute 30. Oh yeah, I'm on a roll. I'm telling you, unless it clouds up, I'm going. Let's see what we got for skies. Oh, here's our summer Milky Way. You can see the summer Milky Way here. There's the rift, the great rift in the Milky Way that Daryl told us about. That's Jupiter. That's Saturn. This is Vega. This is Deneb. Right here. And Cygnus, the Northern Cross, goes down to here and across like that. And then we have Altair, the eagle, down here. Aquila, the eagle. And so these three stars form the summer triangle. Okay. Deneb, Vega, and Altair in Aquila.
When you see the summer triangle, as I've often said, Homer Simpson saw cowboys in the sky. When I look at the summer triangle, I see the big slice
of pizza.
Pizza.
Yeah. Sure does look that way. Yep. Okay, let's see how our minute and a half shot comes out.
Cindy, the Horsehead is in the constellation Orion. It's in the morning sky right now.
Don't worry. It'll make its way into the evening, Cindy. And by the way, hi, Cindy. And hey, Shelly. Shelly Egbert, nice to see you. Thank you for coming out and joining us. Let's see if that was worth it. I think this filter needs some focus. Okay, and we're gonna do that. So let me see here. Let's do the following. Let's move up north. First things first. I'm gonna back us off to the visible light for a moment, or the straight through, and I'm gonna bring us up to a brighter star, maybe one of those two. Let's see if that works. Maybe. Difficult to say. Okay, gonna have to back off again. I'm just trying to focus a little better now. And so I'm gonna find our brighter star. Let's see if that one will work. Yes, it will. Okay. Okay, we're gonna use this star to focus a little more critically. Okay, so now it's out and focus in. That looks pretty good. Let's try that. And we'll just do a quick photo. Yes, I know the nebula is down below. Let's do 15 seconds to check focus. Go Captain America, I guess you got to blame Daryl for that. Oh, I'm so
It's not
silly.
my fault what I do.
That's what I did. Actually,
What you do?
What I did actually is not your fault at all. I actually focused with the through the lens. I didn't actually focus on an actual bright star. Oh, I just did it the wrong way. Okay, not a problem. I will find us another star. All right. So let's see if I do this and this. What's the nearest really bright star? Let's go that way.
Technology is great when it works.
Yes, I agree. It's great when it works. And we know that it doesn't always work.
Yeah. Like I told you before the stream started, I was considering getting a very simple, non-motorized, non-go-to alt-azimuth mount for my refractor.
Yeah.
Just something I could take out and point at stuff in the sky.
I think that sounds like a great idea. Sounds like a really good idea. Okay, let's just do this. Actually, let me back off again. I think this is NGC. I think this is yeah, NGC. We're in the region of NGC 6604 cluster. And let's see if we can see anything. Oh, I can. Just barely. Just barely. So let's bring it back. Yeah. All right. And now we'll bring this back. And get into focus mode. And that star should remain there when I click into this guy. Wow, it's so barely visible. See, we're looking at it through a filter, a fairly dark filter, so it's kind of tricky. So I'm gonna go and find us another star. I should just go elsewhere and just be done with it. Just go to an actual bright star and just go for that. Okay, like this guy. Okay. Well, if it's gonna do that, oh, we got the dome in the way there. Okay. All right. There we go. We got us a star. See, this is what you have to go through when you're trying to prepare for a good night of photography here. Okay. So, sorry about the blank screen there. Okay, that looks pretty good now. So all that just to focus. All right, now we get out of that and we come back and make our way back to our, well, no, actually, I just did it again. No, I didn't. No, I'm on the right filter. Okay, I'm gonna take a 15-second shot right here and see if the star is focused. Okay. Okay, I think we're good. Alrighty, now we come back and we do this again. This is real astronomy, folks. Real astronomy, be the life of the party. Wild duck. Now we gotta go down here to the aigle. El águila. Here we are.
You were just there.
I know. But now what I'm doing is I had to go to another star to focus. So now it's going to new Ophiuchus, and then it's going to pop back over to here.
Oh, because you changed filters.
Yes.
And had to refocus. Okay.
Yeah.
Excuse me for a moment, please.
Sure. And there is our goal. Hope you guys are having a good time tonight as we proceed to knock your socks off with the views. Okay, and now back to here. And now we're going to do another photo for a minute at 20,000. All right, let's just wait a second to get our guide star. All right, we can get rid of this. God, it's still pretty. Oh, this is still very pretty. Okay, so now we can come in here and take our pictures. We have our Milky Way still overhead. Oh, hold on a sec. Let's go and I think the camera had stopped taking pictures earlier, so we've been looking at the same overhead Milky Way for quite a bit of time now. So let's hope that we're still looking good. Okay, let's go here and see. Yeah, looks better, looks good. Still looks good. Okay. I'm gonna just, no, I keep taking photos. Yes, I have to just go to this guy. Let's darken her up a little bit. There we go. Now the Milky Way is really clear. Look at that, huh? What a night. Welcome to SkyTour LiveStream East here in Connecticut, Northwest Hills. It's just really pretty. Oh, Martian, yes, the instant parallax. That's really cool. Taking advantage of the fact that the probe is so far out there. It's really a really good option. Wow, this is really nice. Look at this. It's amazing what little focus will do, huh? Yeah, you're going away. You're going away. You're going away, and you're going away. These are far better focused. Okay. Nicely. And these are focused as well. So now we have some good focus shots. So now we can go back and first I have to just check to see where we are with the oh yeah. Okay, you know what, guys? I'm gonna turn up the music for a minute until Daryl gets back, and I'm gonna go move the dome a little bit more. So I'll be right back. So I'll be back.
Back. What have you all done with Mark?
Okay.
There he is.
Yeah, sorry about turning up the music, Daryl. I mentioned while I was away I would turn it up and hopefully get back before you. I had to move the dome one more time. So
Thank you, Katie.
Yeah, Martian, it's actually telescope ops at all times. You know, it's like, you know, we when we're looking at like, for instance, in this mode right here, this is our mode where we have the telescope controls. We call it ops, you know, dome ops. And then up here we have the camera control cluster, and when we want to, I can show you what's going on in the dome. And this is a pan and tilt camera, so we can actually just, I can grab and move it and just check out what's going on in there at any time. And that's important. We'll have that option out in Arizona as well. Gas mask? You're absolutely right. It's aliens. Absolutely correct. Look, the bottom line is this. When you look at all the science fiction, almost everything that we've dreamed up in science fiction has become science fact. So, in a sense, are we making up what we see in the universe just because we dream it? Oh, that's a question. Okay, this is... Look at this, Darryl. Can you see all this? Look at the detail in here, Darryl.
Whoops.
Yeah, this is... We're going to be looking at some really, really fine detail. I did that critical focus, and that makes a huge difference, of course. And you can see how... You can see all these little areas in the eagle that, are there. These little additional... convolutions, I guess you call them. And it's beautiful. I mean, you can see some of them here, but this is less so.
Yeah.
So what I may do is just see if I can take this narrowband filter and get a shot that's worth its weight in gold. Who knows? Maybe, maybe not. Okay, so we're still in our shot here. You can tell this will blink. The L will become white again, saying that we are ready for another photo.
May I make a point expanding a little bit on when you were talking about doing critical focusing earlier?
Please do.
Folks, if you're ever at the eyepiece in a telescope and you're trying to focus, especially if you're looking at an extended object like a nebula, try to find a star and focus on it first. A star is a point object, point source, and try to make that star absolutely as small and crisp as you can. And once you do that, then go to the extended object, because that is your point of best focus.
That's right.
That's it.
No, that's true, and that's why I took the time to go off of the eagle to a bright star and focus just on the star, because it's effectively, as far as the telescope is concerned, they're at the same distance. As far as the telescope's concerned, the telescope can't differentiate, 10 light years from 1,000, okay, or 0.2 light years from 1,000.
And if you're at the telescope using an eyepiece or using more than one eyepiece, some eyepieces, especially if there are different focal lengths within the same brand, series eyepieces, whatever, that they're called parfocal. And that supposedly means that they come to focus at the same point. What it really means is they come to focus at about the same point. Yeah. So even if you're using a set of parfocal eyepieces, you're probably going to have to fine tune each one.
I could draw a diagram, and so could Darryl, to show you how light focuses at different locations through a lens. Red light focuses differently than blue light in different locations. And the idea is you try to get the focal points to be in the same place, because remember, you got a curved lens now and a flat plane, like that you're looking at, like with a camera or whatever. So the light,
the focal plane.
Yeah, that's right. And the light that comes through the lens, the curved lens from the edge, is going to come down to the focal plane. But the light that comes through the center is going to also come down to the focal plane. And it's going to go different distances. So you have to focus at the same effective distance. And that's the problem that people have with these with telescopes, is that you've got to try and make that focus the same focus distance. And that's not an easy trick to do, but luckily the eyepiece makers have done that for you as best they can, I should say.
Yeah. It's also why you often see so-called apochromatic refractor telescopes, which are total lens systems, no mirrors involved. The really good ones will have 3 lenses up at the front stacked together. It's called a triplet. The so-called apo-refractor I have actually has 2 lenses, a doublet. One of them is ED glass, which supposedly helps, but I guess the idea is because like red, green, and blue all come to focus at different points, that gets them all focusing at the same place with the 3 different lenses.
Give you an example.
And that's why refractors cost so much.
Yeah. I'll give you an example of a real-world application for making focal planes, making focus all occur at the same focal plane. The Kepler Space Telescope. The sensor on the back of the Kepler Space Telescope is actually a curved sensor, right? It's curved because it actually takes care of, it's accounting for something called Petzval radius curvature. What is that? Well, it's just taking into account how light focuses at different places as it comes through a lens. And by curving the sensor appropriately, they were able to make sure that all the light focused at the same plane. And so when you've got millions and millions of dollars, you can come up with a sensor that's actually got a curve in it too. And that's what they did.
Yep. And they did that back in the day with the old Schmidt cameras.
That's right, they did.
Schmidt cameras are very low focal ratio telescopes. You're talking, f2, f3, f4, something like that. And they used pieces of film, chips they called it. And the film holder actually had a very precise curve put in it. And when you put the film in the film holder, you had to physically open the telescope, reach in and place the film holder, and then close the telescope and expose the film. And the film was actually curved because of the fast F ratio. It was difficult or impossible to get a flat focal plane, so they used curved film.
Which is kind of interesting too, because they could only curve the film in one direction, but it's a spherical curve. So they could only bow it one direction. They couldn't make it a compound curve.
Right.
That would make it wrinkle. So I mean, it still didn't do everything it should, but it did get you a lot better footage, a lot better imagery. I remember looking at Schmidt cameras when I was a kid and going, I want one of those. And I imagined having to have a dark room so I could go load all these little film holders, because you had to do it in the dark, especially because you're using a single frame of film. But it became too cumbersome, if I recall. So that was too bad, because that would have been nice.
Yeah. Well, they're very low power wide field cameras. But they've been superseded by technology. I've seen large observatory class Schmidt cameras for sale on government surplus sites before.
Yeah. Well, now
they're specialized. Some people probably still use them, but I'm sure even they are digital nowadays. The idea is the same as what you said with the web, though.
Yeah. Well, see, the way this telescope works that I'm using right now, I'm taking advantage of a protocol, which is a software that's available that can allow you to control your telescope remotely. That protocol is called ASCOM, ASCOM, and ASCOM allows you to do many things at once to a telescope through your communication ports or the USB ports on your computer. So I've got like 4 USB cables coming out of the SkyTour LiveStream East computer in there, and they go up to the telescope to a variety of places. They all do different things. The focus is one thing, the camera operation's another. The dome control, that is to say, what I've written for dome control that will be effective out west but not here, is yet another. So it's basically a pretty good operating system. And I just looked at it and said, hey, this looks like something that can work, you know. And not only that, I actually thought and figure that I'll be able to write my own focusing program as well. So, you know how I had to take the time to focus this, you know, run out to the other star, focus, all that? I won't have to do that. I won't have to do that, because what I'll do is I'll actually write a program that's going to minimize the size of the star image automatically. It can sample the star image and it'll make the star image as small as possible. Okay? And then once I get that, then, in other words, what I do manually now, I can just have the telescope do by itself. And it'll report. It'll report when it's done, when it's focused, and then, boom, off I go. I don't know why I don't think that's such a big deal, but maybe I should think it's more of a big deal. But I don't think it's a big deal, especially with the microcontrollers that you can use nowadays. Now, my telescope's entirely run by what's called an Arduino, which is a beautiful microcontroller system. And I got actually a number of Arduinos. You know, you might have heard of Raspberry Pi. Okay,
oh yeah,
yeah. But basically, Arduino is a more capable Raspberry Pi. In this particular case. Now we have Arduino Mega, which has more addressable ports, if you will, and I'm using the Arduino Unos because I only need to have about 13 different addressable reports. Donald Kunzer, TOC means table of contents, but I can't put the whole words up in the description up above because it doesn't show up. It's just too short, too long rather. So I used to be a computer programmer in the past, and I found that I do more programming after having left that life behind than when I was actually doing it. I really enjoy doing what I do now. I am looking so forward to just doing astronomy full time. Of course, I have a visual effects business, and we shot a sample for A&E Network yesterday here because I'm hoping that they'll see that my son's production company can actually do the job for them. So he did a fine job. So I'm looking forward to seeing what he comes up with. And but at least it gives us a chance to showcase some of their talents. So I'm still doing that kind of work, and that's okay. So that'll never go away fully. Obviously, that's gonna always be part of what I do. Oh, that one didn't come out too well, did it? Okay, we'll just get rid of that. So I figure I'd delete the bad ones as they're happening. Oh, that's a bad one too, isn't it? Yeah, that's a bad one too. That's round, that's better.
One of my brothers was a IBM mainframe kind of guy. What he trained on, and heck, when I was a kid, I remember him bringing home cardboard boxes full of punch cards. And all his career, he worked on mainframes. There's still people using them. I don't know about nowadays, but up until the point he retired, there was a demand for mainframe guys. The bad part was they called him at 2 or 3 in the morning a lot, you know. There was a problem. He was one they called. And
He was on call.
always. He must have made 4 times what I did, but it was like a 24/7 job.
I knew a guy.
He finally hung it up.
I knew a guy that worked on mainframes. These are big computers, and I said, "Oh, how can you work on these giant mainframes?" He goes, "Why?" He says, "The mainframe's just a big PC." That's what he said.
Yeah.
It's like, not really.
At least they did away with the punch cards by the time he retired.
Yeah. Okay, I'm in the middle of a periodic correction. Or periodic error. So I had to wait a couple seconds.
Like I said, this is all, like I said, you know, technology is great when it works. I've got go-to mounts. I'd like to get a simple Altaz mount for the refractor.
Yeah.
Just me and the telescope. I would probably make this the new grab and go scope. I have a grab and go scope now. It's a 5-inch Maxitov.
Okay.
And I just run it on a camera tripod, which is not very user friendly.
Okay. But the Altaz mount is and Altaz mount. Okay, we're still in this periodic error spot. I gotta get rid of this. The Altaz mount is one where it's like pan and tilt. What's that?
I'm sorry.
Oh,
You froze there for a minute.
I did? Oh.
On my end, at least.
Okay. Well, the Altaz mount it's like a left, right, up, down, a pan tilt type mount. To those.
Yep.
And what we're using is in here is a version of an equatorial type mount, but we're using a fork mount where you have these arms that come up and the telescope tube is in the middle of them, and the arms go this way and that way, and the telescope goes up and down. So you get this up and down and the left, right, but it's leaned back to follow to line up with the pole so that it spins right on the Earth's axis. And that allows the telescope to follow the rotation of the stars or the movement of the stars across the sky.
Mm-hmm.
Well, you know that. I'm just telling everybody else.
Oh, yeah.
Yeah.
Oh, believe me, even when I ask you a question, it's like the old lawyer's creed, don't ask a question you don't know the answer to. A lot of times if I ask a question, it's for the benefit of chat.
Of course. There's very little that you don't know.
Maybe head off questions at the pass there, so to speak.
Sure. That's all good. Let's check our sky and see what we got going on here. Okay, good. Look at the Milky Way, Daryl. Look at this. Not bad, huh?
Right.
Milky Way.
Like the moon's down, too.
Yeah, the moon's gone. We got a horizon to horizon Milky Way tonight. Look at that. In spite of the fact that we've got a lot of water vapor in the air. So that's pretty good.
It is.
Yeah. I can tell you this. 5 years ago, the sky here was not like this. It's actually getting darker because we're a dark sky state now, and state funds aren't pulled if you're going to put in outdoor lighting that shoots light up into the sky. So that's pretty cool.
I wish.
Well, I know, that's just terrible.
There is a town here in Colorado. It's a little place up in the mountains called West Cliff, Colorado.
Okay.
And they pride themselves on being a dark sky location.
Okay.
They promote themselves as being a dark sky location. I've never been there after dark, and hey, that's all well and good, but I saw some images of West Cliff at night recently, and they use unshielded light fixtures, which kind of blows a hole in their whole self-promotion,
Yeah.
And I see people taking pictures of Colorado at night all the time, and ooh, isn't it beautiful? And the light pollution is just rife. It's everywhere.
Yeah.
Can't get away from it. Colorado's being loved to death.
Yeah.
I hate to say it. It's been my home going on 50 years now, but it ain't what it used to be.
Yeah, that's just terrible.
Development at all cost.
Yeah. Well, we've talked about this before, Daryl, and the orange glow lights that you used to see all over the place are the sodium vapor lamps. And then the mercury vapor lamps, okay? Many of those lights, those are great for astronomers in that if they were in the air or in the sky, you could actually get rid of them. You could subtract them by just using your using your filters to take care of them. But unfortunately, when they added the LED, they changed over to LED lights. That was a problem.
Yes.
Yeah, that was a problem.
Broad spectrum.
Yeah.
Bright white. And Colorado Springs here, they kind of bent the knee, at least, sort of toward zero cutoff or full cutoff light fixtures back in the 90s after I did a little consciousness raising about it here in town. But they have gone with LED lights, and they seem to have a particular fondness downtown because they're cute for the zero cutoff Victorian style light fixtures.
Oh yeah.
Which just spray brilliant white light everywhere. They're lighting up the tops of high-rise buildings with these things. It's atrocious.
Yeah.
You talk about mercury vapor lamps. Those things are awful in their own way. The rural electric cooperatives out here, you get outside the city limits, and if you're not on city utilities, well, you go to the rural.
Yep.
They would give away mercury vapor lamp fittings free to their customers.
Really?
And, oh yeah. If a farmer wants to light up outside his barn, they'd give him a mercury vapor lamp, and for free of charge, they'd come out and install it in the whole 9 yards. What they didn't tell the farmers is they use 10 times as much electricity.
Yeah.
And most of their output is in the ultraviolet, where it's not doing any good anyway.
Yeah.
They may have changed since then, but I wouldn't bet on it. I know I mentioned before a guy in the club, he bought a piece of ranch land out about 30 or 40 miles northeast of town. And when he bought the property and started building his little piece of heaven, there was not a single light visible from his property.
Mm-hmm.
But you go out there now, and it's just a sea of lights as far as the eye can see.
Yeah, see, that's why we're doing this out in the desert, because where we are, there's no encroachment.
Yep.
Yeah. And I was very careful to look at the new developments and what are going to be going in over the next several years. And there are no new developments going in. But then again, all the developments that go in have to adhere to the full cutoff lighting rule. So if you as a homeowner decide you're going to put in a light that aims up at your house and illuminate the front of your house, you can be stopped legally from doing that. Now all it takes is well, typically what I would do is I would approach the neighbor and say, hey, you're using this full cutoff fixture. I know you spent money to buy it, but if you want, we'll go halves on our new fixture that won't throw this light up into the air, okay? And just because of trying to be in a gesture of goodwill, you're violating the law, but we can get around it, and I'll help you do it because you didn't know. So, and I would actually do that for them,
Well, a lot of people don't know or they don't care. A lot of people here, they light up their yards like prisons, they use spotlights and floodlights, and it's impinging on neighboring properties, and they don't care. Or they put up these stupid bar lights, which are popular in commercials nowadays, which are string after string of naked bulbs.
Oh yeah.
And
you just sit there with your.
They don't care.
Sit there with your BB gun, especially at night. Hey, why not?
We have the technology for that. I'd shoot out the neighbor's light I've complained about before with him and his crop of tomatoes, and
yes.
Except he's got cameras everywhere, and he'd probably see me do it. And I've tried to get along with him, so I wouldn't do that anyway. But it's annoying. People don't know, and most people just don't care.
Yep.
Architectural lighting is a big part of the problem that gives all these bad ideas. That.
Oh yeah.
Architectural lighting, they think it's great. Let's put a light down at the bottom of a high-rise building and aim it straight up so it lights up our building real pretty. And that's just bad practice. But and people want to light up their gardens and their trees at night. It's silly in my opinion, but people do it.
Yeah,
they saw pictures in a magazine, or they saw a neat picture on a commercial, or they saw it at the bar.
Yep.
Big city stuff.
Mm-hmm.
Part of the problem here, we have a lot of city slickers moving in from out of state, and they flee the messes from their old homes, and they come here and they do the very same things that made the mess of their old homes.
Yeah.
And they cannot be reasoned with.
Well, they tend to think that what do you know?
Right.
Who are you to tell me what to do? That's the entitlement mentality, which actually is. I don't really stand for that because, it's like there's a neighbor here who just moved in. Never met the guy, but he will take his motorcycle, leave the driveway, and because it's a motorcycle, it has a loud engine. So he has a stereo on the motorcycle that's even louder than the engine.
Yep.
And he turns it up. And we're 120 feet off the road. And we can't hear ourselves speak on the front porch when we're sitting looking over the lake. Because you got this guy going down the road with the roar of an engine. And over that you hear this shrill music playing. And it's like, if I was down there and I had an air horn, like, a train horn that people have that they put on their vehicles sometimes, they install a new compressor and they actually have a, like a boat horn.
Yep.
I would lay that on there and I would probably shatter his motorcycle into millions of little pieces from this boat horn. And then he'd be just sitting on the road on his butt and his jeans and his little biker boots. And I'd be like, oh, I'm sorry. What happened? You couldn't handle the noise, huh? Or I'd go out in front of his house at 1 in the morning when he's in the house and just turn around in his driveway and just lay on that horn for as long as the compressor can do it. I think I'd actually get some really good satisfaction out of that.
Well, good luck with that.
That would be a lot of fun.
Oh,
Wow.
that's known as loud pipes save lives.
Yeah.
Those are the guys that make their motorcycles real loud on purpose because they think, well, gosh, they can hear me coming, so they won't run over me.
Yeah, and I mean, there is some actual logic to that, and I understand it. But you also have to look at the fact that the cars nowadays are so much better at keeping noise out that the realistic expectation that you're going to hear somebody coming is not there anymore. You know?
Yep.
All right, this is the last picture we're going to take here, and then we're going to head up to someplace else. Because we are reaching the edge. So if I get rid of this and just... There we go. That's the equatorial view. So we're actually almost setting with this stuff. But we still have... Up high, we still have... Yeah, there is the North American. It's still well over... let's see, how are we there? Oh, duh. Let me do it this way. Yeah, this is still... We're still at like, 79 degrees. That's going to be beautiful. So we're going to check that out. And here's our last shot of the eagle, and it looks good. And it's a good one to end with because the eagle, end this series of photos with, because the eagle is definitely getting low in the sky now. All right, so let's see now. Back here. And let's... All right, let's make sure now that the telescope is going to be able to point where we want it to. We'll see. It probably can. Did you have a request that you wanted to see something, Daryl, before? I think you're on mute. Daryl? Uh-oh, did your computer do what I think? No, you're on mute. Okay, he'll be back. He's on mute. Oh, Ronald, I'm sure he would say you're welcome. All right, let's go.
You're welcome.
Hey, there you are. You were on mute.
Yep.
That's okay. All right, let's go and head up to this location. Watch the telescope over here in the view. You can see what's going on here. And even hear it moving. We'll see a star show up, hopefully. Here we go. There we are. And let's... Might have to move the dome again. If this doesn't align right, then we have to move the dome. Okay. So it says we're about there, but I'm not sure. Let's go into the white light image to, or say image says straight through pass through. As you can see, these are out of focus because the white light, that is to say the straight pass through hole without a filter, is not focused. So, but this is actually helpful because it kind of looks like this. So maybe, let's see. We got 1, 2, 3, 4 stars there. Yeah, that's these stars right here. 1, 2, 3, 4 is 1, 2, 3, 4. So let's go. Oops, not that. Let's go back and look at this. I want to get us down here. So all we have to do is move those stars higher in the field. I think doing this will bring us to that dark part of the nebula, that little bay that we saw, which is here. So that's sort of where we are, huh? Well, let's try it. I look forward to the opportunity, sir. First, we got to go back to this first filter. And now we will look at the all sky. Looking good. Uh-oh, clouds. No, go away. You are not wanted here anymore. Luckily, that's toward the north and should be moving exactly that way. All right, so now let's go into our view here. Bring this guy up. And now let's do a 1 minute at 20,000 here as well and see what we have. We should have a guide star right now. If this doesn't work, it means that the telescope cannot see that location in the sky. We might have a problem with the way the telescope is facing, because the guide scope is right on the other side of this, and that might be blocked by this part of the dome. Look, domes are great, but when it comes to doing this kind of unobstructed sky views, they fall short. And this dome may be for sale in the coming weeks as I move toward getting a shed out there. When this telescope gets packed up to go to Arizona, I'm going to also convert this over. I have no choice. Got to do it. But I won't do it until we're operational out there. So we'll have a telescope running at all times, hopefully. Okay. Now let me see here. You can see me better now. The reason is because I need to bring up this light again and edit it. There we go. There we are. Oh, wow. We hit that one right on the money. Look at that. Here is that area. Wow. That looks beautiful.
Is that Gulf of Mexico?
Let me, I think so. Hold on. We're actually right there. So, yes. Can you see the Gulf?
Uh-huh.
I think that it's over here. I'm going to have to... this is the noisy view, and this is the processed. I think I can actually fix that a little bit. And move it. Get rid of this for now. I'm glad it does the guiding very nicely right now. This is good. Okay, so what I have to do is move this over a little bit more. So let's head this way. Wrong way. Feldman. Remember the character called Wrong Way Feldman?
I remember Wrong Way Corrigan.
Okay, it was Wrong Way Feldman. It probably is a play on that one too. Wrong Way Feldman. All right. What was Wrong Way Corrigan?
I'd have to look him up. I forget what he did. He
Okay.
flew an airplane the wrong way, I think.
Okay.
Something like that.
Hey, remember those clouds? Katie Q, you gotta stick around here more. Or were they here? Well, they were here, right?
Yeah.
Yeah. Well, they went away. Katie Q said, "Away with you clouds," and look at, they're gone. I mean, literally gone. And this is, we got a new photo that's coming in momentarily here. And we're taking a picture here, so let's wait and see what this one looks like. Okay, here it comes, ready. And okay, and look. No clouds. Well, hey there, D. Smith. So good to see you. Marianne sent me pictures of her boat on the tow truck. The boat is up on the tow. I think that's hilarious. That's funny.
Wrong Way Corrigan was an aviator. He was American. After a transcontinental flight from Long Beach, California to New York City, he flew from Brooklyn, New York to Ireland, though his flight plan was filed to return to Long Beach.
Oh, God.
He did it on purpose, I think.
Oh, okay. That's hilarious. That is so funny. Okay, I know where this little location is. And we I believe that is I think that's this area right here. Alright, and then once this comes back, I'm going to move it just a tad to jog it around. Take care of making sure that it dithers right.
Looks like gas mask beat me to it.
Okay, but you had said that, yeah?
Yeah.
Wrong way.
I would think he had to have done that on purpose. I mean, if you want to go to California from New York, you're going to have land under you all the way, and he must have noticed the Atlantic Ocean at some point.
Well, if it was clear.
Right.
He could have definitely flown on overcast, and he would be doing it all in one day. It wasn't an overnight flight or anything, unless it was night. Was he flying at night?
Don't know. I closed the window. I'd have to look it up again.
Yeah. Well, he was actually immortalized in a movie where Wrong Way Feldman was a character in the movie. And I think, he was an aviator who always flew the wrong way. So I think that's where that came from. I never knew that.
Yeah. Well, 1938. I mean, that's still early on.
Yeah.
I don't know what they would have had for.
It was Gilligan's Island,
Oh,
where Wrong Way Feldman appeared.
okay.
Yeah. Hmm. And I think that the guy, he was like a bearded old guy, and he was like, "Well, hey, I can fly wherever we want to go. I'll take you there." You know, he had that kind of voice. You know,
Yeah.
really funny guy. No, Gilligan, we'll get you home. No problem. It goes this way. Or was it that way? You know. So Wrong Way Feldman. Alrighty. The guiding is good. The timing is long. And okay, and now we'll do this. Good night, Donald. Thanks for coming out. Donald, you're a trooper. Yeah, 3-hour tour. Isn't that funny?
3-hour
tour. A 3-hour tour. Remember the rest? The weather started getting rough. The tiny ship was tossed. If not for the courage of our fearless crew, the minnow would be lost. Da-da-da, the minnow would be lost. The ship's aground on the shore of this uncharted desert isle, with Gilligan, the skipper too, the millionaire and his wife, the movie star, the professor and Mary Ann, here on Gilligan's Isle. Boom. Not that I ever watched it a lot.
Yeah. I identified with the professor.
You know, Russell Johnson was very good as the professor. I identified with him as well.
And I preferred Mary Ann.
Yeah, I mean...
The eternal question, you know, Mary Ann or Ginger, what her name?
Tina Louise.
Yeah, Tina Louise.
Dawn Wells was like the country girl. And Tina Louise, I just don't understand why Tina Louise would have got on this boat by herself.
Yeah, dressed like that too.
Yeah. And then of course the Howells come in with the trunks of money, lovey. Okay?
Yeah.
They had trunks of money. Heavens! Thurston, we have to go. Yes, whatever you say, lovey. And every time he would talk, I would hear Mr. Magoo. Yeah,
exactly.
Hey, I don't know what I'm doing. That was just funny.
Same guy, wasn't it?
Yeah, Jim Backus. Yeah. Jim Backus was just funny as heck, you know.
Nowadays, I suppose the eternal question would be asked about Elsa versus Anna. I guess it is.
The Green Acres?
No, Frozen.
Oh, I thought you were talking about Elsie. I'm sorry, it was Elsie. Oliver. Remember? And then there's Mr. Haney on Green Acres. That'll be $12. Get out of here, Haney! And he runs away. Everything was a cost. You know? Very, very funny. So for those
I liked Arnold the Pig.
Arnold the Pig was really cool. Yeah. I like the guy. I forget the guy. The farmhand's name that like knew Arnold and always would talk about Arnold. I forget his name.
Zeb?
Yeah. It was Eb, right? Wasn't it Eb?
Something like that.
Yeah, I think you're right. Yeah.
And Mr. and Mrs. Ziffel, the farmers.
That's right.
Arnold's parents.
Yep. Remember that? You are my wife. Goodbye, city life. Green Acres is what was it? Is Green Acres something. Dun 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 bum bum. It was cute. And do you remember? Oh, do you remember the Underdog show?
Sure.
There's no need to fear. Underdog is here. The secret compartment of my ring I fill with the Underdog Super High Energy Pill. It was actually a show that advocated using drugs to little kids. You know?
Wally Cox, wasn't it?
Yes, it was Wally Cox. And he would take a pill and put it in, and you see the American flag show up in his eyes, and ta-da! And he was strong. Wow. Oh, yes. That's Mr. Ed. Right? Remember that? Hey, Wilbur! You know? Mr. Ed was great, you know? Now, Ed, you've got to just calm down. I'm not calming down. What do you call it? What was that guy's name? What was the owner's name? I mean, and the song, of course, is unforgettable. A horse is a horse, of course. And no one can talk to a horse, of course. That is, of course, unless the horse is the famous Mr. Ed. Go straight to the source and ask the horse. He'll give you the answer that you'll endorse. That is, he'll always talk a steady course. Talk to Mr. Ed. People yakety yak a streak and waste your time a day, but Mr. Ed will never speak unless he has something to say. A horse is a horse, of course, and no one can talk to a horse, of course. That is, of course, unless the horse. Da-da-da-da-da-da. I am Mr. Ed. Remember that? That was the theme song?
Yep.
I guess I remembered more of that for you than you really wanted to know.
Gas Mask mentions my favorite Martian, which I was about to.
That's right. My favorite Martian.
Ray Walston.
Ray Walston. I never watched that show too much, but I really liked how he would sit still. All of a sudden he would sit like this, and you'd see the little antennas go, you know?
Yeah.
I thought that was such a cool effect, yet it was such a simple visual effect prop. What did I know? You know, as a little kid, I loved seeing antennas come out of his head, which is what I thought they were doing.
Yeah.
Mommy, how do they do that? It's TV magic, dear. Okay. Wow, TV magic. I want to do TV magic someday. Dennis,
I thought his spaceship looked pretty neat.
Yeah, it was a pretty cool ship. Classic flying saucer, wasn't it? The little round one, or was that a Twilight Zone episode?
The one I seem to remember, it was streamlined, maybe kind of an ovoid shape. It had a little cockpit back on the back.
Okay.
Small windows in it.
Yeah, I'm confusing it, I think, with something else. Yeah. Man, this is something else.
And there was Dobie Gillis, which was a little over my head as a kid.
I never watched Dobie Gillis. Do you mind if I gotta run out. I gotta run out and move the dome. Okay? Can you hang on?
Okay.
All right, I'll be right back.
Sure, Underdog. What was her name? Polly Purebred. And I forget the bad guy. Of course, there was Snidely Whiplash and Dudley Do-Right, and what was his girlfriend's name? Wasn't Polly Purebred. It was something Trueheart, I want to say. Oh, for the good old days. You watch some of those shows nowadays, and you know, I think some of the good ones, they operated on two levels. You know, it was something kids could enjoy, but there was some adult humor, subtle adult humor stuck in there too. Rocky and Bullwinkle might have been like that sometimes. And what was it? Help, Mr. Wizard, help. It's the dog with the time machine and the kid that went with him.
Okay. The next shot's going to look a little different. Because this entire last sequence, we've actually had the dome in the way a little bit. So, we're going to have to dump them. I hate that. See, that's a little better. And then it got progressively worse, see? Arg. Crap.
Yeah, Rabbit, Natasha, and Boris.
Boris, we got to get Moose and Squirrel. Hey, Rocky, watch me pull a rabbit out of my hat. Nothing up my sleeve. Presto! Brr. Must have had the wrong hat. Remember that?
Oh yeah.
Yeah, I liked the Bullwinkle show. That was, I remember. Boris, we got to get Moose and Squirrel. Natasha, hey Natasha. Mm-hmm. Okay. Yeah.
Thank you, Daisy and Zoe. It was Mr. Peabody and Sherman.
Oh, right. Peabody here. Sherman and I gonna set the Wayback Machine to 1790, where we're gonna go back and watch Charles Messier find all these crazy objects in the sky. Oh, let's go, Mr. Peabody. Remember those? Sherman, and that was a great show.
Oh, yeah.
Great show. Oh, yeah, look at this. Now that's more like it. Yeah, that was fun.
My favorites from back then, Popeye. The later Popeyes were not well animated. The ones I really liked were the really old Popeyes.
Oh, yeah.
They had some. They started out simple animation too. They got really ornate later on. TBS used to show some really off the wall stuff late at night, and
Yeah.
there was a time back in the 70s, I guess, where they were showing Popeyes I had never seen before. I mean, some of these things were
Black and
almost like
white.
movie length. They were very long, and they were full color,
Oh.
very elaborately painted, matte shots and stuff. With the Jeeps and they were just really trippy. I always wondered the old Popeyes if they weren't on something when they made those there.
When Popeye would
That was-
speak, he would never stop talking. Remember that? He'd always be mumbling to himself. He'd be like, "Oh,
Yep.
well, I gotta go get the olives. Oh, I gotta go. Skip up. Whoa, hey, look out, Brutus!" You know, remember that? That's like he was always talking, always mumbling. You know, so that was a hard voice actor part to do. And then, of course, there was Brutus. Hey, Popeye, whatever. And if I could have a hamburger today, I'll gladly pay you Tuesday. Not now, Wimpy. I don't have times for you. And he was just like all over the wall,
Yeah. They used to have a lot of them on YouTube. They may have pulled them. I'm not sure. I caught the old classic I Want to Be a Lifeguard Popeye episode on there a while back. That was really funny. I want to be a lifeguard.
Like,
they're both showing off in front of Olive and the girls.
Yeah.
It's funny.
I wants to be a lifeguard. Oh, okay. We can do that. Maybe I can do that.
Oh, once he ate his spinach, at one point he turned into like a octopus, and at one point he was swimming like a submarine, and his pipe became his periscope. I think that's pretty crazy.
Yep. I'm strong to the finish because I eat me spinach. I'm Popeye the Sailor Man. Boop boop. trying to get these pictures, and they were supposed to be coming out easily, but they're not. And I'm wondering why, because when I had the dome in the way, they were coming out perfect. And now they're coming out a little... Maybe it's because I'm in the periodic error point. Hey, there's Isabella. How are you? Did you get your photo of the bubble nebula that I left for you? You asked for it, and I sent you a copy of it. Yeah, the schedule is when it's clear. I think YouTube still sends alerts, but the alerts are not the same as before. Yeah, we got a declination error there, so... Okay. I am now going to go lower that declination error, so I'm doing that right now as we speak.
Mark, will you excuse me, please?
Sure.
Yeah, I'm running out of steam here.
Oh, okay. You want to go off and go to bed?
Yeah,
All right.
I think so.
No problem.
All right, well, thanks for having me on. It was fun tonight.
Yeah, we got to see a really cool bunch of things, man.
Okay. Take care, everybody. Have a good night. See you soon. And good night, everyone.
All right. Good night, Daryl. Thanks for coming
night.
out with us and hanging out.
Sure.
All right.
See you soon.
All right. Bye-bye.
Bye.
Well, there you go. And I'm just going to continue to change my settings here for a minute. Okay. All right, we'll try that now. Let's see if that's gonna do what we want it to do. Let's go see, shall we? I'm up early? Who said that? Tara? What do you mean I'm up early? It's a beautiful night. Kinda. Well, let's see what the sky looks like. Yeah, look at the Milky Way. Come on. I mean, that's beautiful. It's like, ooh. Yeah. Okay, so let's get back out of this. And let me see if I can grab a photo that actually looks like it should. Alright, we'll just do it. Bond. James Bond. You expect me to talk? No, Mr. Bond. I expect you to die. Remember that? The laser going right in between his legs. Ah! Yeah. Well, KDQ, you want to fly into the Milky Way, then I think what I might have to do is do another indoor stream where we actually fly through the galaxy, because you can actually fly through all the stars. They just go by you, and it's the actual stars in real positions. It's really quite nice. Oh yes, I watched Gravity, as you asked, Gas Mask. Oh, thank you, Isabella. I'm glad you listened. And I think you might have answered the question, but you did get the photo of the bubble nebula that I sent you, correct? You asked specifically for one. Okay, see, now that's better. Much better. Okay. All right, we're in business. Now I can keep going. Let me go back to this, by the way. Okay. We're looking at a nebula. This is the nebula here. And I will pull that out in the processing, and you will see it. Oh, the NASA box. Yes, indeed. Thank you. You know, it's all true stuff, you know. The person that sent me that NASA box, as I said, was now he's the chief engineer for all outer space missions in the Outer Space Directorate at JPL. Gentry Lee. Gentry Lee. Oh, Isabella, I didn't see your thank you. I'm so sorry. You see, when you go into the notifications, it doesn't wait for you to click on the notifications. It just makes all of them go away, and it's like you saw them all. And then I lose track, and I'm going through, and I missed that. But thank you so much. She was answering my question about whether she got the Bubble Nebula picture for it that I sent her, and she did, which is good. Okay. Really? We're done with that? Another one. That's nice. Okay. And let's go take more and jump back here and check it out. Oh. You did fine, Isabella. No problem. I should have just gone through and figured where the end of the list was. And I didn't. But I will do that next time, I promise. I'll be more careful. Yeah. That's correct, Tara.
I'm strong to the finish because I eat my spinach. I'm Popeye the Sailor Man. Boop boop.
Remember that?
Oh, I got to get me spinach. I need gas in my car.
Gask, you know. He always had a funny way of talking. Remember Woody Woodpecker? Woody Woodpecker was voiced by a female voiceover artist. She was quite famous, actually. Oh, Silent Running? You talking about Huey, Dewey, and Louie, the three robots on the Valley Forge spacecraft? Yes. Doug Trumbull's the guy that actually made that movie. He actually bankrolled the whole movie. He got Bruce Dern, and then Bruce Dern was perfect for the role because he was sort of a tree hugger type person, and he played that part well. And then the robots. I watched. See, Doug. You know, I work with Doug, and he has this behind the scenes. Presentation he does for a lot of the movies he's worked on. A lot of behind the scenes stuff with like Close Encounters and Third Kind, 2001, and so forth. And all the rigs and stuff to do the special effects, visual effects that you see in those movies are Doug's responsibility. So if you were really attracted to Silent Running, you're attracted to a ship that Doug designed and put together, and he did a lot of the work himself at that time. And he actually managed to really pull together a heck of a show, a heck of a movie. Now, the Valley Forge was actually the name of the spacecraft, but it was actually done on the actual Valley Forge aircraft carrier out in, I think, San Diego, before it was going to be broken up and scrapped. So because it was going to be destroyed, they were able to make it over in the interior passageway. So all the scenes where they're in the ship were done inside the Valley Forge aircraft carrier. And the Huey, Dewey, and Louie robots were actually double and quad amputees inside custom-made robotic shells that they would wear. One of them actually walked on his hands. He was like a human torso. He'd walk in his hands, and that's why he would hobble. Okay, and the bottom was very short because he didn't have much of a torso. But another one had a longer torso, and she had to walk. She had to walk on her hands, and so she would have to walk on her hands too. She'd walk along, because that's how she got around every day. And then to rest, she had a long extension on the bottom, of course, because her body was in there, but she would just relax her arms, and she could sit down for a while and just sit inside that outfit and rest in between takes. And there's some scenes where you actually see them with the headpiece off, with the shell on top off, and you can actually watch them, resting and eating and drinking. It's really funny, to see how it was made. It's really quite a good, well-made movie. And Doug had the imagination. Oh, it's beautiful. Doug had the imagination to, and the wherewithal to actually offer a showcase for these double and quad amputees double amputees to actually do what to show off that they had skills. They're real people, and it was really a good program to illustrate how, just because you're missing a couple of appendages doesn't mean that you're down and out and you're out of it. They were vital. They made the show happen. They made it. Without them, it wouldn't have worked. So there's a lot of really clever sequences in there. Doug talks about how he got Janis Joplin to sing the song. If you remember, the song was "Gather Your Children to the Sun," something like that, and it was really a pretty song. And he got Janis Joplin to actually sing it. And after hearing about it, she basically did it for him. So it was really quite an astonishing, get, if you want to call it that. So I think that's a neat movie, and I ate that movie up. And then Doug and I were working at the studio on a commercial, and I'm stumbling through some of the back closets because I had to get some parts for this Burger King commercial we were actually doing, and I happened across something that makes me just like freeze in my tracks. It was a piece of the Valley Forge spacecraft. I was like, oh. I just like stared at it. It was a dome with all this fancy wire wrapping on it. It's one of the domes, one of the eco domes. Oh, incredible. And I just loved it. So I told Doug about it. Well, I didn't really, because that commercial was the first time I had met Doug. So when I looked at him, I just went, and he kind of understood what I meant. He goes, yeah, I'll get back to work. So that was kind of interesting, not kind of, it was very interesting. So that was a fun way to meet someone as famous as him. I mean, he was my idol. I modeled my FX models after how he did things. I modeled it after his approach. Gosh, it was just so much fun, So yeah, and then let's see other things that happened in. Oh, there was one. Oh, remember in one of the geodomes, Bruce Dern decides to take a swim. Um, Now, they filmed it on the Valley Forge. They did that, but the domes were filmed elsewhere. And when they filmed that part of it, there was a pool that they had to swim in. And Bruce Dern swims in the water, and he comes up, so refreshing. What you didn't know is the water was like 35 degrees. Because whoever filled it, they didn't warm the water. And so Bruce Dern, he was freezing his butt off, and he had to make it look like he wasn't cold. He had to make sure he didn't shiver. For the most part, he did. Okay, but man, he actually was. He was actually really, really cold. So in between takes, Dern was a big, health fanatic and so forth. What he did was he would go up onto the aircraft carrier deck, okay, and jog up and down the aircraft carrier deck. He'd go exercise. When he would do that, he tended to lose track of the time, as I recall. And he would have to be chased down by someone down below. Bruce, you're on. Come on, we got something. Oh, okay. Well, don't be so upset, boys. I'll be down. Very nonchalant, very laid-back guy. And then, of course, they did it. They said he was a marvelous person to work with. Actually, they really enjoyed working with him. Now, another movie that Doug did that you may not know, and that scared the heck out of me as a kid, was Andromeda Strain. That was another one that he entirely bankrolled on his own. And that one, when that virus would just multiply, boom, boom, and it would make that little music and see boom, boom, and then the geometric shapes would change. It's like, that really scared me, because I felt like that could actually happen. And, in a sense, it can. At least with a pandemic, there's a way out. So, I think that it's probably a good, a good movie to watch if you haven't seen it lately. Jet pilots flying over and their planes disintegrating out underneath them because all the rubber is melting away and disintegrating because of the virus. And it made their blood turn to powder. Remember, they sliced open the guy's arm and it's like the blood came out as like powder. All those things, had to think of the effect and how to deliver it in a way that would really work. That was cool. So Andromeda Strain was a good one, and that was Doug Trumbull again. Of course, 2001: A Space Odyssey, How about Star Trek: The Motion Picture? He did that too, as well. Yeah, Tara's right. It was very scary, The other one he did was Brainstorm. Brainstorm was a movie that he did with Natalie Wood and what's his name? Come on, you know the guy. He talks like this. Christopher Walken. That's right, the baby crying in Andromeda Strain. Why didn't he die? It's because he had acidic blood from crying so much. But Christopher Walken and Natalie Wood did Brainstorm with Doug, and up at the studio right now. If you go up in the studio, you can put on the helmet that they wore, that he made in Brainstorm. It was a football helmet that they decorated with all this extra stuff, but it looks like a specialized piece of gear, and so it was kind of cool, and that's up there now. So what happened was he, Natalie Wood, of course, died during the making of that movie. And that spelled the end of Doug's life in Hollywood. He was a Hollywood boy, and he grew up in Hollywood. His father did Wizard of Oz, famous for Wizard of Oz. And so he was like in the whole effects world for a long time. And when his father ended up retiring and so forth, Doug took the lead. And when he did Brainstorm, he basically it was a great pleasure working with Natalie Wood. He enjoyed it, but when she died under rather suspicious circumstances, he was very upset, of course, but she had finished all her principal photography for the movie. So they finished the film without her because they didn't need her for the other scenes, and for the other scenes they rewrote them so she didn't have to be in them. That's a good movie to watch too. And what's interesting about the movie is the movie's about a science team that figures out how to capture the images of somebody and see their thoughts. And someone on the team had the bright idea of looking at the footage of a scientist who actually had a heart attack and died while wearing the helmet and recording his imagery. And they wanted to go see what death looked like. I mean, really a fascinating concept. And what they ended up doing was, going down a path that was really dangerous, So that's another one to watch. Brainstorm. Silent Running with Bruce Dern. Brainstorm. Of course, Close Encounters of the Third Kind with Spielberg. He did that. Oh, and the other one he did, Blade Runner. Oh, yeah. With Harrison Ford. Blade Runner. Yeah, that was a good one. That was a movie with Ridley Scott. That Ridley Scott had championed. So Blade Runner was another good one. See, I'm just taking all these pictures, hanging out with you guys, and I'll have this thing processed. Maybe we'll get something cool looking to show up here. Indeed. All right, now we got get a few of these that look good. They're all coming out good now, which I like. Then I gotta take some with a wider narrowband as well. Hey, Dee Dee. Flatliners, yeah, that was another good one. But I was just giving you movies Doug had done. He didn't do anything with Flatliners as far as I know. Yeah, I'm certainly not biased. I'm a science fiction person. So is Doug. Everything he does is framed around science fiction. A couple of years ago, we did for the Super Bowl, we did the iPad Pro commercial for the release of the iPad Pro when it came out. And, okay, we'll see you later, Dee. Thanks for coming. And when we did the iPad Pro commercial, it was all about space. And you can see it on YouTube, actually. It's called Great Big Universe, if you want to go see it. If you look up iPad Pro Great Big Universe, you'll see it. And we had Alabama Shakes do the song for the commercial. And we did about 20 or 30 different visual effects scenes to get a bunch of apparent effects happening, and it's all done in visual effects, not computer effects. No CG except at the end of the commercial. All the rest, everything you see, all the rest you see is actually all done in the studio using special tanks, special liquids, special dyes. We recreated the planet Jupiter in a spherical tank. And when you look at this image of Jupiter's great red spot, you're going to think that it's just time lapse from NASA. It's not. We did it in the studio. I was right there watching it and taking place and working it. So it's pretty cool to be part of that, knowing how you're defying reality, suspending disbelief, and it's really something. Then we didn't know who it was for, and we weren't told who it was for. Doug's the only one that knew, and he wasn't telling us right away. And the reason he wasn't telling us was because he wanted to make it kind of a surprise. So we're doing all these effects. We had one where we had this big cubical tank, a 4 foot by 4 foot by 4 foot tank, and we had this meteorite strewn, crater infested landscape, and it was in the bottom of the tank. The tank was filled with water, and up through holes in the craters we had to make this like a volcano planet. So we had these little holes, and we were pushing up milk into the water and filming it at high speed as a camera underwater was whipping through this like this, coming right at you, and coming right at this right through all the smoke, so right through smoke plumes and stuff. It was really pretty. That footage actually was never used in the final cut, but we weren't in charge of that. The people that did the commercial were in charge of that. So that was a beautiful scene. We did nebulae, going through nebulas with clouds, like this nebula. We actually recreated nebulae like this in a water tank. And if you had a very still tank, you could drop in dyes in a special way and watch them disperse. And then they would end up just floating and hanging. And as soon as they got to that point, we would take a camera, a little micro camera that really delivered beautiful high-res video, and just go sailing through it. We didn't care that it got disrupted behind it, because you saw the thing intact as you went through it, and then it would, you didn't see it get destroyed behind you. What scenes those were. Some of that got used. We had an eclipse sequence that we created with magnets and high-speed water. We had Saturn's ring that we created. Think about this. We had a ball painted like Saturn, okay, that we did. Put it halfway down in a tank of water, okay? It's not halfway down, all the way down. And half the tank was filled with salt water, and the other half with fresh water. Fresh water and salt water separate at the boundary layer. They don't like to mix. So at that boundary layer, we injected dye and put in tiny pieces of glitter that wouldn't show up on camera as anything other than like little tiny ice particles. And the next thing you know, you have Saturn's ring. And you see it going around in the commercial. It's called A Great Big Universe. Check it out on YouTube. Oh yeah, Isabella, it's A Great Big Universe. The Apple iPad Pro commercial, Great Big Universe. And it really, it came out pretty cool. And, I mean, for the most part, it was good. We did like 20 or 30 different visual effects setups, and maybe about 10 of them were actually used. But that's what happens, For Burger King, oh man, we were actually doing a commercial for a new sundae, and I have all that footage. I have all the footage from all this. I mean, I could probably make a whole stream of just showing you all that. And this stuff was the sundae that we were doing this commercial for, and the Burger King people were there. We had special big plush couches for them to come and sit their asses in. And they would actually sit down and watch. And as we went through our daily routine, we used liquid nitrogen curtains dropped from the air, and we'd shoot up looking at them. And as it comes down, it smokes. And those became like transition points for things. Yeah, it was a great big universe. Yeah, Ronald. And then we had big brownies that would split open, and chocolate would come running in, and we'd have a camera come running through it, right up between, racing from one thing to the next kind of thing is how it was looking. And what that did, and what happened was, that was the first time I met Doug, and my job was to build 300 little Oreo cookies, about this big, okay, 3-inch diameter Oreo cookies, actually 3 or 4 inches. And I had to make them so they could be a breakaway, meaning that when they would collide with each other, they would just shatter into millions of pieces. That's a real trick, and I figured out, put vermiculite, aerate the plaster. I made them out of plaster so they would explode on contact. And it took me a while, but I got it to happen. And I made 300 of them. Actually, my son Gabe actually cast up all 300 for me because I was working on other stuff up there. And then after making the 300, we had catapults that we made, and they would launch these cookies, and they had timers on each catapult so they could launch. One was up facing down, one was on the side going in, and one was on the far side coming this way. And they all had to launch, and they all had to meet in the middle of the camera frame. And then when they meet in the middle, they hit at high speed. They go, and they would just break apart into millions of pieces. And the first day we shot that, we were up until 3 or 4 in the morning watching the dailies, watching these collisions we did all day. And all you heard in that room, in the screening room, the whole time was after a collision, you hear, oh, look at that, hey, look at that wall. It was so rewarding and wonderful. What a great thing that was. Had a really good time on that particular shoot. Okay, so we got that. So then the next thing was, okay, we're looking good here. The next thing was, as I was finished working on that particular shoot, the next thing was to and that was the first thing and the only thing I was supposed to do. Then Doug said, "Oh, maybe we need a big 12-inch Oreo cookie, and we have to have it hollow so we can fill it with liquid nitrogen, spin it at 2,500 RPM, and have the liquid nitrogen come whipping out. And we're gonna film that at high speed and blow the stuff coming out back, and it'll look like a comet." At high speed, when you film it at high speed, it slows the motion down. So we'd have this comet coming, Oreo cookie comet coming at us like this, trailing all this smoky debris, the cometary tail. And so I said, I can do that. And Doug said, all right, you're the one. Little did I know, it meant that I had to also get the motor. I also had to build a rig, and I also had to make it spin at 2,500 RPM. It was more than just building a cookie. Go figure. Actually, I have the cookie in the other room because I used it to do a visual effects class for the University of Rhode Island. So, when the when the commercial came time to be done, and we filmed it, the entire shot, the cameraman and the whole shot, it was this. Here's how it went in real time. Okay, spin the cookie and action. And the cameraman would go, and that's it. 1 second. And that was the whole shot. And that led to about 45 seconds of cookie coming at you because we shot it at 1,600 frames per second. So all those frames in that 1 second was translated to this long, slow motion of a cookie with all this liquid nitrogen coming out. It's a good thing too, because after 6 seconds, that rig froze up and we go and seize up because of the cold. So we had to stop anyway. So it's a good thing we didn't need more. And we couldn't heat it because that would negate the liquid nitrogen's beautiful effects. So after that was done, after we did that one, then Doug said, all right, can you do this? Maybe you can do this one, and maybe you can help with this one. And I said, I can help you with the brownie thing. I can make a rig to split the brownie apart and do the whole thing. So there were like about 14 different visual effects. Visual effects is, organic, it's happening in camera, no computers. Special effects is computer generated stuff. So there were 14 visual effects setups, and I ended up working on 13 of them. And that's my first time ever meeting Doug. And so at the end of the last shoot was my spinning cookie, the high-speed cookie. and he basically that was the last scene for the whole shot, and the shoot was over after that. And when it was done, you have to understand, Doug never talked to me once. I thought, well, this was nice working with Douglas Trumbull, and oh well, I'll go home and just say I worked with Doug Trumbull. Little did I know, he had spies that were watching, namely the guy who was directing all of the visual effects shots. And Doug said, okay, as I found out, how about this guy Mark D'Antonio? What did he do? And Lou, the special visual effects guy, I suspect, said, well, he did 13 different setups with us, and he made them work very well. He did a very good job, having never done some of these things before, because it was my first commercial ever. He said, fast learner, blah, blah, blah. All the right things, I guess, because Doug decided to continue. He says, I want to continue with you, and because you were just really good, according to Lou. I'm like, wow. And I was shaking because this was still Mr. Trumbull. And you have to understand, my first day there was not so a little bit ignominious, because we were testing the catapults, and the catapults that just had springs on them, and when they would shoot the wooden puck that we used to simulate the cookie that was going to all collide in the middle for the shot, it would shoot at like 2 feet. It had to go 20 feet, you know. So I saw surgical tubing. Hey Doug, can we use the surgical tubing to make this a little bit more oomph and make these catapults shoot at a higher speed? Sure, have at it. Yeah. And I thought to myself, Doug Trumbull liked my idea. Yeah. Well, I wrapped up the surgical tubing on all these catapults, and Doug's son John looked at me and said, I don't know, that looks like too much surgical tubing. And me, Mr. Big Shot, I'm thinking, no, come on, hey, you know, this'll be all right. Should we just test one? They go, all right, we'll test one. So we set one up. We set this wooden puck that weighs about the amount as a cookie, set it up in the catapult, and he is going to go set it off now. And he goes, I don't know, that's really strong. I said, I think it should be okay. Yeah, famous last words. So all of a sudden, you got a picture now. Doug is outside, okay, and these are garages in a visual effects location at one of the buildings. And all of a sudden, Doug is outside, and he hears the catapult go off, you know. And next thing he hears, a split second later, is a loud bang on the garage door. And he thought something had fallen, you know, because there were big lights in there that would cost thousands of dollars. And he thought something really bad happened. He comes running in. He goes, what the hell happened? And I was about to say, yeah, I put too much power into the catapult. And I looked to my left, and his son is pointing at my head. Like him, he's the one. And I thought, I am so fired. And Doug says, you dented my garage door. I go, I know, I'm sorry. I put too much. He goes, well, you're on the right track. I like the idea. Just take off some of the windings of that tubing. I went, oh, okay. And he walks out. He says, good job. Keep it up. I'm like, I'm so not fired. And his son goes, you're lucky. I go, I am so lucky. And from that point on, it was really funny that we actually hit it off very well, because Doug, if you know, is also a UFO hunter, like I am. We're both UFO folks. We believe in extraterrestrial life and all that. So we had many long conversations about that. And when work's not involved, we actually really, we just like click on a lot of that. We did a movie up there called Into the Unknown. It was a movie about an astronaut going to Mars by himself. And he had a team of people come in from outside. They were basically using his expertise as a consultant. I was there as his chief scientist, as he called it. And then the people had these ship designs, these spacecraft that they wanted to design. And they were pretty much said and done. They said, yeah, this is what we're going to have. And I looked at the designs, and I kind of quietly mentioned in the design meeting up on this mezzanine level of the studio, I said, I was looking at your ship designs. This is supposed to be scientifically real, correct? Because Doug Trumbull does not want to do anything that isn't plausibly scientifically accurate. And they go, well, yeah. I said, okay, may I make a comment? Well, sure, go ahead. The spaceships, as you've designed them, won't work. And they were silent, and I thought, oh great, what did I just say? And Doug didn't say a word, and I had no idea what was coming next. And then the art director, kind of, art directors have a little bit of their own ego to fight through all the time. He looked at me and said, oh well, the ship designs are settled and we like them. And that was that. I went, okay. And Doug said, excuse me guys. He goes, if Mark says it's not going to work, it's not going to work, and I think you ought to listen to what he says. At least hear him out. And now this guy who was previously like, yeah, okay, thanks, we've heard enough, thank you. Now he was like, oh, please tell us. Is that okay, Mr. Trumbull, if I tell you? Because they respected Doug. They didn't know me from Adam, and they, whatever, I understand that. So I told them what to change, and they changed the ships, and guess what? They worked, because they actually had to work on the set. Okay, so they needed to be balanced, so that if they were to spin in zero gravity, they would actually not whip all over the place, So we figured out a way to make them balanced with counterweights and stuff, and have them visible counterweights, so that the ship would actually function like it should. And when the full-size ship, which was like 12 feet in size, was actually spinning on the set, it actually spun correctly, and it didn't go and start to try and move all over the place, as it would if it wasn't counterweighted. So that was really a good thing. So you see, and that's the power of Doug's world. He likes to see things plausible, scientifically plausible. And he knows there's a place for computer-generated graphics too. Okay, and that, but it's really been kind of cool. But our latest thing up there is the creation of these pods. Doug's got a concept in his head of having theaters that are literally spherical screens all the way around. If any of you have ever been to Disney World, you've probably been on the Back to the Future ride. If you've ever been to Las Vegas, you probably went on what's the ride he did out there? It has to do with pyramids. I forget. Luxor Pyramid. Okay, there was a Luxor ride that you went on. If you've been in Las Vegas, the Back to the Future ride in Disney was a Doug Trumbull production, start to finish, and he did everything. He made that ride what it was. He created the cars, he created the movement, all the things, and it was really just an amazing opportunity he had. And he did it up in Sheffield, Mass, in a little building up there. And then for the Luxor ride, he did the same thing. And the Back to the Future ride was the longest running ride ever that they ever had in the park. That's pretty cool. So enough about that. I know I've kind of gone on and on there, but I kind of was, I'm doing these picture after picture after picture of the North American Nebula segment here. And for those getting bored, I apologize, and I hope you can, pardon me for boring you a little bit, maybe. But for those that are interested, hey, there's a lot more that he's done. There's really amazing stuff. But we'll talk about that another time. So let's see here. I don't even know how I got down that path. I have no idea. Oh, Isabella, you should see how some of these things are done. You'd go crazy if you saw how easy some of these are done, and also how elaborate some of these can be. Well, thank you, Dee Dee. I think that when you look at, like right now, Doug and I are doing a movie on Nikola Tesla. I'm part of it. I'm helping him. We've been to Buffalo, New York, where we flew over Niagara Falls with a helicopter and did 3D movie footage from the air and all kinds of stuff. Then we were 300 feet underground in a dam and we were going down these long tunnels and making them all 3D. Really, really cool stuff. And there's a big statue of Nikola Tesla there because he was actually very prominent for the city of Niagara and the electrical grid there. You know? Yeah, it's true. That's true. I am a bit of a geek when it comes to that stuff. But I just have a head for it. You know, I just see like Doug will say, okay, we need something to do this, this, and this. And I'm like, oh, I see a way to do that. And he'll say, yeah, okay, yeah, that sounds good, but I like my idea better. Here's what I want to do. Okay. He is the master. Well, anyway, there was one, we did a movie called Ufotog, which is one that was a demonstration film of our entire process. One of the things that is interesting about that movie is that I had a cool opportunity in that movie because when Doug did 2001: A Space Odyssey, you remember Hal, that one little eye that you saw, the eye of Hal, that red thing? Okay, every time you saw Hal, you heard a little noise. It was like, it was like the hum of the computer all the time. That was part of that mood, setting up the ambient atmosphere. Well, we for our movie, he wanted to have two cameras side by side because it was going to be in 3D, and the scientist that was trying to call UFOs was actually recording himself with these two cameras. And he said to me, he goes, "You want to build a new HAL?" I went, "Yes." So I did. Okay, 1 second, I'll be right back here. Just a minute. Okay, sorry about that. So let's see here. Where did I leave off here? The Tesla movie is called Imagination. And I gotta tell you, the guy that we got to play Nikola Tesla, he's a Shakespearean actor and he's very, very good. And you know what's weird? You will absolutely feel like you're looking at Nikola Tesla. He is a dead ringer, and just amazing, dead ringer. And he knows how to talk in a Croatian accent too, which makes it even more of a mystery. So it's pretty cool. Okay. I want to stay, but I can't. I gotta go to bed. You know what, folks? This will be the last exposure right here. And then what I'll do is I'm going to put all these together. And when I say all these, I mean all these. I will put together and stack up. All right. So you'll get an Eagle Nebula. You'll get this segment of the North America Nebula. And what was this? Oh yes, a globular cluster. I can make that available too. That's measure 22. Wow. So yeah, we had a good time, let me tell you. This music sounds like the, well, the show's over music, doesn't it? And I want to thank you. I want to thank all our sponsors. I want to thank you guys for coming out tonight. And we want to thank our special guest, Daryl Mason, for joining us tonight. And we'll see you on the next SkyTour LiveStream, right? I mean, that sounds kind of cool. Well, folks, it is time for me to shut down and can it off for another night. I didn't know it was going to be clear tonight, but it is. And I hope you benefited. Hope you guys had a good time. I will talk to you on the other side or as soon as tomorrow if it's clear again. All right? Good night, everybody.